Welcome to this ArcDR3 Global Student Forum, Confluence and Transfer, Ideas and Exchange. I begin proceedings by acknowledging the traditional custodians of this unceded land on which I am presenting, the lands of the Wurundjeri people of the Kulin Nations, and I pay my respects to their elders, past, present, and those emerging, and to all Indigenous and Torres Strait Islanders witnessing this presentation. My name is Professor Donald Bates. I'm the Chair of Architectural Design at the Melbourne School of Design, the University of Melbourne. It's a pleasure for me to be able to host this event. It's really been something that we've really looked forward to as a kind of, not so much culmination, but certainly a signpost in the development of projects. I want to say just a little bit about the background to both the work, but also to this initiative, the ArcDR3. The ArcDR3, which is Architecture and Urban Design for Disaster, Risk Reduction, and Resilience, is a global initiative that has invited 11 universities from regions with recurring risk of natural disasters to participate by engaging in a collaborative research studio that pursues new strategies for risk-resilient environments across the Pacific realm. By establishing an international platform for the production and exchange of knowledge on environmental design that reduces the risk of recurring disasters and enhances resilience, ArcDR3 aims to create a more effective integration of theory and research and practice and design. Participating universities include UC Berkeley, UCLA, and University of Washington in the USA, Pontifical Catholic University in Chile, the University of Tokyo, and Tohoku University in Japan, University of Hong Kong, Tsinghua University in the People's Republic of China, the National Cheng University in Taiwan, the National University of Singapore, obviously in Singapore, and the University of Melbourne here in Australia. Across the globe, 21st century cities face a growing number of technological, social, and environmental challenges. The increased intensity of global risk establishes an urgency to define new strategies for designing buildings, cities, and environments. Over many years, scientists, engineers, and scholars of such events have accumulated much knowledge to help elucidate disaster-related phenomena, structures, and systems. However, there are limited scenarios in which experts find the opportunity to apply this knowledge at a large scale in the field of reconstruction or construction that anticipates future events. To bridge such gaps, the X-Lab at the UCLA Architecture and Urban Design faculty, in partnership with the IRIDES at Tohoku University in Japan and the Mericon, the National Museum of Emerging Science and Innovation in Japan, have established the ArcDR3 Initiative as part of the APRU Multi-Hazards Program. The ArcDR3 Initiative takes its inspiration from the Sendai framework, seeking to propel it forward using a collaborative approach to architectural education and to demonstrate visionary design possibilities. The goal of the initiative is to contribute to cutting-edge design thinking towards the development of an international standard for risk reduction in the urban environment. At the conclusion of this initiative, ideas formulated by participating universities will be shared with the Japanese Ministry of Economy, Trade, and Industry towards a view of establishing the content for a new disaster risk reduction certification for the International Organization of Standardizations, ISO. One of the objectives of the ArcDR3 initiative is to develop this conceptual approach that sets a foundation for the development of alternative, sustainable, regenerative design models for the future, and something that enables urban designers to prepare for the complexities of the changing urban environment. Regenerative urbanism is envisioned to address these unprecedented changes through an adaptive systems approach, with the focus on regenerative and evolutionary design and development strategies for ecologically, sociologically, and technologically resilient cities. It expands the notion of resilience, and it implements an alternative complex form of adaptability where resilient design responds and adapts to change, whether a sudden shock or a long-term trend through the establishment of evolutionary regenerative system, ERS. As a platform, the joint initiative draws from an international network of professional and educational partners. To this end, the experimental educational project will share, store, and utilize ideas created and implemented by participating universities under the umbrella of the ArcDR3 Grand Syllabus to be adopted and modified by each participating institution within its local context. With a holistic goal in mind, ArcDR3 participants will design ERS, these evolutionary regenerative systems, for risk and resilience through one or a combination of the following lenses: the lens of technology, of society, or of ecology. The challenge to participating teams is to realize bold, interdisciplinarily conceived urban design proposals that smartly tackle at both a local and a national level key points identified in two of the four priorities for action for the disaster risk reduction laid out in the Sendai framework, which these were the Sendai framework priorities 1 and 2 and priorities 3 and 4. Participating teams will demonstrate ideas at two scales of urban design: systematically, or in the form of a large-scale network, and prototypically, at the scale of a smaller node in the network in the form of a constructed environment. This event today, this forum, is an opportunity to display and to interrogate the most recent studio projects and to hear directly from the students who are the authors and team members in the research and design process. Going forward, these and additional projects will be displayed in exhibitions and compiled into a publication for public distribution. Now, I just want to set the context for today. Beyond this welcome, we will go into looking at the projects and the themes, starting off with water, and we'll have an introduction by senior lecturer Lara Asensio Valoria from the University of Melbourne, then 4 videos from the universities, and then a question and answer session with the students. After that, we move into the session on earth, wind, and fire with an introduction from Professor Jeffrey Inaba at UCLA with 5 videos from the universities and then question and answer. And then finally, we move to multi-hazard with an introduction by Professor Roberto Morris from the PUC, Pontifical Catholic University in Chile. There will be 4 videos, one after another, and then a session of question and answers with the students. At the conclusion of this, we'll move into a larger conversation where we'll have representatives from 6 different universities, as well as the 3 previous hosts, exchanging ideas and really starting to work through some of the issues and the aspects that have come up in the presentations. We've tried to leave a sufficient amount of time to really get into deep conversations and exploration of some of the ideas based on the work and the designs. Our final section is really moving back to the students. We have all been working effectively in a single global disaster, which is the pandemic of COVID-19. And we're interested to hear from the students who have had to participate and try to go through their university education, but also to work on these projects of the disaster while in the midst of a disaster. So we'll hear from a selection of students from 4 of the universities to talk about what it's meant to work under the age of COVID-19. This session this forum will conclude with some closing comments by Professor Hitoshi Abe, who's really the initiator of this whole thing. So to get things started, I want to welcome now onto the stage senior lecturer Lara Asensio Valoria from the University of Melbourne to speak about the thematics of water. Lara.
Thank you, Don. So hello, welcome to the water session of the ArcDR3 Global Student Forum, Confluence and Transfer, Ideas in Exchange. As Don said, my name is Lara Asensio Valoria from the University of Melbourne, and I have the great privilege of introducing the teams in this session. In this session, we will have presentations of studio projects focusing on architectural, landscape, and urban responses to water-based risks from the University of Washington, National University of Singapore, Hong Kong University, and the University of Melbourne. All projects produced by the respective student representatives. Having had the privilege of seeing the works before this event, I, for one, am excited to see the range of approaches that are brought to this wider topic of water by all the teams. It is also fascinating to see geography and cultural context assert a very clear stamp on the projects, and to see the diversity of issues, constraints, and identified opportunities specific to each team. University of Washington offers inventive social infrastructures for a number of sites vulnerable to the impact of tsunamis. This includes inventions in housing and community constructions, which challenge the conventional over-reliance on large civil engineering structures to offer resilience, which is firmly embedded in the community. National University of Singapore's master plan offers a strategy for how cities may be transformed to live with water. Their archipelago provides the site on which the students have devised architecture which project new lifestyles for an inundated Singapore under climate change. Hong Kong University innovates with the typologies of its high-density urbanism to more intelligently negotiate with severe storms, flooding, and sea level rise. Conventions of the high-rise type and the ways it lands on the ground are transformed to respond to these threats. And the University of Melbourne team presenting today focuses on restructuring one of the most crucial practices supporting urbanization, agriculture. The team aims to transform this into a more regenerative process and offer tangible ways that it may address water-based risks of drought and storm events exacerbated by climate change. The presentations will proceed in the order that I just described. We will start with University of Washington, followed by National University of Singapore, then Hong Kong University, and lastly, we will move on to the presentation by University of Melbourne. After this, we will dedicate some time for representatives from each school to field questions from members of the other presenting teams. So thank you very much, and I would like now to invite all of you to view the presentations of the water teams. Thank you.
CBS News, quote, with the current global temperature level and rate of temperature increase, I believe that we could get 5 to 10 feet before the end of the century.
Hello everyone, we are from Professor Suter's studio dealing with sea level rise in the East Coast region of Singapore. Singapore, being a nation located along the tropical belt, has had torrential rain as a problem long before its modern city-state. However, the dangers do not stop there. With the imminent threat of rising sea levels, water continues to be a factor of misfortune for Singapore. Among the affected regions, the East Coast area of Singapore stands out to be one of the most heavily affected by rising sea levels, with over 70% of its land elevation 5 meters below average mean sea level.
The devastation of rising sea levels would affect about 100,000 people who call East Coast their home. On top of that, the reaction of materials in contact with salt water also pose dangers and economic losses to the livelihood of the community. In response to the nation's land scarcity, various land reclamation methods such as the traditional dredging of soil from neighboring countries to sinking caissons were developed through many years. However, these methods resulted in political tensions and devastation to coastal marine life. Despite the repercussions of their actions, the government has decided to establish land reclamation as a major strategy to combat rising sea levels. We felt that this approach would only be delaying the inevitable. On a social and cultural level, it would also blind vulnerable communities from the realities and dangers of sea level rise. The issue, by its nature, is not something that can be solved with one technical solution. It is something that has to be habitualized in our livelihood through a piecemeal approach of introducing water into East Coast gradually, making use of the duration Singapore has before sea level rise reaches a critical point. As flooding is the main issue, the studio used topographical analysis of the site to identify low-lying areas of East Coast, which determines how water would behave. Land subsidence was also recognized as an infrastructural issue that has to be dealt with throughout the whole master plan development.
The master plan is a heavy modification of today's flat and man-made landscape into one of natural mounds and basins that allow water to flow freely throughout. It would be a continuous evolution and adaptation to the predicted flooding situation, working hand in hand with the forces of nature to remain relevant and ready for situations beyond the control of humanity. Through the development of the master plan, we took into account of making small changes to the movement of people and infrastructures over an extended period of time. Various factors such as the existing urban fabric that could influence the livelihood of the community were considered extensively. Transport and infrastructure will continue to evolve together with the development of the master plan even beyond 2150. Allow us to play a video illustrating the transformation of our master plan phases. Throughout the master plan phases, we are exploring these three main questions: of transition, of new living in the East Coast, and creating a resilient mindset.
The first challenge that the community will face is identifying the sense of familiarity within a familiar landscape that is changing. Memories are paramount to develop a sense of familiarity of a place, which is manifested through constant exposure to personal items, which serves as a form of security and reassurance in a transient landscape. The project is conceived as an enclosed resilient storage facility with spaces for individuals and a community that allows them to revisit and reconcile with their personal items. This helps to ensure their place in the East Coast is retained amidst evacuation, construction, and extreme weather. Using the sense of familiarity attached to objects, the state of bliss between individuals and items aids in the form of psychological reassurance where the last chapter of the old environment unfolds into a new chapter of the new environment.
How do we then enable a resilient, self-sustaining model of living in the face of the new urban scape? My project aims to seek out the opportunities latent in the master plan for self-reliant living by taking advantage of the master plan to enable the processes of rewilding hand in hand with anthropological cycles. The hunter-gatherer operation is reintroduced in the scheme, combined with modern office work operations. The residential typology is modified from ground up to its interiors to reflect these new operations and work life cycles. In summary, the scheme allows for an integration of anthropological sequences with natural cycles, creating an anti-fragile ecosystem that allows for both humankind and other species to coexist, enabling a new self-reliant way of life.
As our master plan progresses past its eventual phase, the importance of transition and new living, as illustrated by both Cheryl and Clarence, are fundamental to observe what life will be like on the mounds we have created. However, there is also another important lesson to be learned throughout this entire process. To end off, I would like to assert the reminder that disaster never ends. The project I have developed is centered on establishing a culture that is resilient to disaster. In a process of degradation, healing, and celebration, amphibian devices are introduced as the mounds disintegrate from the continued effects of natural forces. These devices provide the means of assurance both through its purpose as warning systems, healing structures, and as items of festivities, reminding its inhabitants the day water taught them to be resilient. In summary, our master plan and individual responses capture a glimpse of how our community can learn to adapt, respond, and thrive in the imposing threat of rising sea levels in East Coast. Thank you.
Hello everyone, here are Tom, Zhenyu, and Shanmei from the University of Hong Kong. It's our honor to share our studio work with you here. Our studio is called Adaptive Towers on the Climate Change, led by Professor Weijun Wang and Associate Professor Ulrich Kirchhoff. Since the 20th century, global climate change has led to rising sea levels, frequent typhoons, heavy rain, and extreme temperature. Facing such challenges, sustainability, resilience, and adaptation have become the critical agendas affecting the next generation of architecture. The studio will challenge the typical Hong Kong high-rise typology and its predominant podium tower configuration, exploring a new kind of tower that is adaptive and resilient to the changing environment.
So here is the first project presented by Tom here. We were assigned to different coastal conditions in Hong Kong. For my group, our site is at Kennedy Town. This is super close to the entrance of Victoria Harbour, where flooding always occurs during the typhoon seasons due to the insufficiency of seawall. The first step of intervention is the site transformation by researching and comparing the artificial and natural edge conditions. An adaptive stepping site is designed with buffer pools in between, which is resilient to storm surge and rising sea level and hence resilient to flooding. Model is made during the intervention to test and illustrate the ideas. For the tower transformation, detailed research of existing podium tower was done in exploring the possibility of transformation. It has found that the intensity of hurricanes and typhoons is rising under the consequence of global warming. In recent years, a maximum wind speed of 250 km per hour is recorded in recent typhoon in Hong Kong. In the beginning, due to the rising intensity of typhoon, I started to design a tower that is resilient to wind on the top, but at the same time adaptive to water at the base. I wish to dissipate wind effect on tower through designing an aerodynamic form in order to prevent extremely wind conditions. For day 2, I am thinking I should design a tower which is adaptive to wind instead of prevention. It is time to think about why don't we catch the strong wind and use it as passive ventilation and renewable energy instead of dissipating wind effects on the tower. Therefore, a new form of adaptive tower was born. This is a perforated shear wall structure that the structure itself created wind channel to accelerate and funnel the wind into the tower for passive ventilation and renewable energy. CFA was used to test the wind penetration, and passive air exchange system is decided in each of the units by making use of the wind for passive ventilation. Since my tower is located at the coastal edge touching the water, the base of the shear walls are made by eco concrete, providing surface area for biofilm in preserving marine ecology. Natural growing of oyster and mussels provide a dominant effect of the water filtration next to the shoreline. As a result, a new type of tower typology which is adaptive to the changing wind and water environment is decided. Different scale of physical models were made during the studio, including structural testing and overall site integration. And here, Zhenyu will present the next selected projects of our studio to you.
I'm Zhenyu, and I will introduce our group's project. The site locates in Shanting, sitting at the foot of the mountain. Vast amount of runoff water goes into the drainage system and flow into the sea. Additionally, the flush of water enables the mangrove to grow near the output. Through calculation, if managed properly, the runoff water collected would be enough for the daily use of local residents for 9 months. Then we study how the water flows from the mountains through the highway and the residential area and goes into the sea. We map them out in the master plan level. According to the simulation of rainwater route, we set 3 dam-like podiums to collect the runoff water and make connections between them to form a community. This is the section of the proposal. Water is stored at the back of the tower and will be filtered and pumped into the tower for daily use. From the isometric, we can see that they also have a route for the water to flow from the upper part to the lower part. At the output, we set a messing to block the sediment and keep the mangrove ecology. For the individual tower design, we took different structure elements, shear wall, transfer plate, and exoskeleton to innovate them for rainwater collection purpose. I take the transfer plate in the high-rise as a water collection device. Using the sponge to simulate the force situation, I extract the invalid part to form a communal space and water storage tank. The plate stretch out the facade to collect the rainwater going down from the facade. In the tower scale, these transfer plates connect to each other to allow the water flow between them. The excessive amount of water would go down to the underground water tank through the core.
I'm Charmaine, and I will talk about our project at Lei Yu Moon. Our site at Lei Yu Moon has a dynamic duality where artificial and natural developments coexist. The left side of the site is mainly man-made developments, and the right side is a natural village with still houses built alongside the coast. In between the two sides, there is a typhoon shelter with an artificial pier built to protect the ships and boats inside. This is a section that cuts through a public housing and a private residential tower walking towards the village. Since the site is prone to flooding during typhoon seasons, there are various artificial flood controls to deal with the issue of flooding, such as rock armor and seawall. In order to soften the coastal edge and promote ecological growth at the site, we propose to replace the artificial flood controls with natural structures that are porous, which help to dissipate wave energy and allow coral reefs to grow. After that, we began to position our towers, and a water flow experiment was done to determine the locations of the towers at the site. Our hydraulic experiment shows that a man-made island at the entrance of the typhoon shelter facilitates water flow and promotes the process of sedimentation at the typhoon shelter. We have 3 towers with different performative structures at different locations of the site. One stands at the junction between the land and water, one catches sedimentation and forms its own island, while the tower at the side stands in the water, connecting the land with the man-made island at the entrance of the typhoon shelter. This photo shows our 1:500 site model of Lei Yu Moon. My design of the bubble tower derives from 9 circles arranging in a square, and the form of the podium, structures, and the living units follow the curves of the circles. Funnel-shaped columns are designed to be the major supporting structures of the tower. The podium of the tower is designed to be tidal reactive, with pontoons floating on water, making the podium accessible during both high tide and low tide. During high tide, water would flood the podium, creating tiny water parks for children to play. At the top of the tower, there are funnels to collect rainwater to be biofiltrated and reused in different zones of the sky gardens, and they are temporarily stored for irrigation. Finally, excess rainwater will be released to the sea through the central column. And this is a photo showing my 1:100 tower model. This is the end of our presentation, and thank you.
Regenerative hydroscape aims to improve efficiency of water collection and water usage through the actions of cultivating land. To help alleviate the disruption of the water crisis and the risk it is bringing to the regeneration of urban areas, the proposal focuses on the agricultural industry, as it is the second largest carbon producer throughout the world and takes up 60% of water usage throughout Australia. The poor management of waste from yielded crops contaminates surrounding soil and water. A centralized waste treatment can be better monitored and maintained. It can utilize the waste to generate outputs, which has a positive impact on farming practice and the environment. To demonstrate the proposed system, Bales will serve as a test site to be able to form an evaluation of the combined farming practices and aquifer storage that have been used throughout the world. Bales is within the Carradina Shire and has a low salinity, a landfill site that recycles producible waste, and a fresh deep aquifer that is suitable for human consumption. In Australia, the drought has worsened due to the decline of rainfall. The rising temperatures of 50 degrees plus evaporates water running along the surface. Therefore, Melbourne's water storage has dropped significantly, especially during the period from 1996 to 2010. Meanwhile, flooding gets more extreme due to climate change. Our site, Bales, has a long history of alluvial flooding. To utilise existing drainage, we propose a system to mitigate flooding water for managing droughts through aquifer storage, which helps to increase the efficiency of water diversion and harvesting. Aquifer is a key element for groundwater banking, a strategy for water storage which prevents water loss from evaporation and secures water supply in the longer term. The project is proposing a new form of small-scale regenerative farming system that considers water as a resource in Bales. It performs as an ecosystem of soil, aquifer and waste energy, demonstrating the cycle of how the system will improve the two main subjects of drought and flooding.
The strategy for rehydrating soil is the leaky weir system. In Bales, the soil is a monomerous clay loam which has low salinity, a pH of 5 to 7, which is suitable for implementing leaky weirs. Leaky weir systems enable water to flow underground through the soil, which improves soil health and any surrounding flora. Based on water flow direction and contour, leaky weir will be placed at a relatively lower point of ground to collect water. Land is accordingly redivided into lots to allow water runoff flowing into leaky weir and wetland. The strategy for filtrating and collecting water is the wetland cell system. The layer of wetland and natural sedimentation is designed for water filtration through slowing water velocity and planting root treatment before water has been collected through UTFI. UTFI, the underground transfer of floods for irrigation, is the implementation used to mitigate floods for managing drought situations through aquifer storage. To further develop the efficiency of water usage, we adopted Australian common-use bay border strip irrigation for its long-distance coverage, supplemented with traditional zigzag method to control water speed and prevent soil erosion. The strategy for improving the local water cycle is regenerative farming. It helps to increase water holding capacity of the soil by rebuilding soil organic substance and restoring soil biodiversity. This reduces carbon emissions, which also serves to mitigate climate change effects. The system proposed mixed crop and livestock rotation as strategies to improve ecosystem services such as pollination and biological control. During drought seasons, water will be drawn from aquifer for irrigation, for farmland, and the artificial forest. During wet season, rainwater will infiltrate into land, and UTFI will recharge the aquifer. Zooming into a smaller and human scale, the program of waste-to-energy plant utilizes agricultural waste as input to produce energy for human use. It supports educational and recreational facilities nearby, such as the forest and short-stay area. The waste-to-energy plant is a small-scale infrastructure to process organic waste collected in bales, such as manure, food waste, and crop residue. It converts waste through anaerobic digestion, breaking it down into digestate, a nutrient-rich material for plant growth, and biogas for electricity and heat generation to support daily life and agricultural practices. Due to lifespan issue, the plant has to change the configuration for equipment replacement. Vacant area will turn into an aquifer museum to promote the system of water banking in bales. Meanwhile, the plant also displays how the proposed water system can be applied on an architectural scale with the implementation of UTFI and mini wetland in the landscape. Next to the waste-energy plant, the closed landfill supports the plant through providing biogas and energy crops. The plant uses digestate to create soil berm for artificial forest. The forest further prevents soil erosion and increases the ability to produce clean water to alleviate the water crisis. The tip of berm collects most of the water for trees, while the rest infiltrates underground or continues spreading downslope for other species.
In conclusion, while facing two major climate concerns of drought and flooding, the close interaction between soil, waste, flood management and water collection through the architectural strategies can support the replenishment and management of water, which will improve the local ecosystem and farming activities.
thank you very much to all the teams presenting for those very inspiring and interesting presentations. I hope everyone enjoyed them as much as I did. Congratulations. We are now going to move to the Q&A session, as Don and I introduced earlier on, where each of the teams will have the opportunity to ask the teams in our fellow universities questions they might have about the projects. There will be 4 minutes allocated to pose the question and deliver the answer, and I'll be keeping time, so I'll interject if I have to, but I hope not to. So without any further ado, let's move on to National University of Singapore, who will be asking a question to University of Washington.
Hi, I am Clarence. I'm representing National University of Singapore. So having seen your presentation, it seems like you have these individual interventions that focused on like one aspect or one area of the townscape. So I'm curious, how does these various interventions consolidate together as a cohesive, holistic solution for Westport?
That's a great question, Clarence. Thank you. My name is Christina. I'm from the University of Washington. Our studio was organized into 4 big groups. So these kind of 3 themes that you see in the video are people focusing on different water-related hazards and creating interventions based on those. But the 4th group that isn't as easy to translate into the video was a kind of overarching social intervention that worked on actually programming and trying to come up with different social interventions that could activate the different structures and vertical evacuation facilities that folks were designing in the studio. So one of the interventions was at a proposed VES, a festival to happen every year that was an opportunity for people in Westport to not only practice their evacuation drills in the case that there's a tsunami, but this festival would also be a place where people can kind of celebrate what they enjoy about Westport, being on the coast, being able to have access to the things that they enjoy in that community.
Okay, thank you very much. So we will now have Hong Kong University asking a question to National University of Singapore. Thank you.
Thank you. Hi, I'm Gavin from the University of Hong Kong. And my question for the NUS project is that what is your take on public space? Because with water rising, the spaces on the ground will be reduced. Alongside with the land scarcity that you have mentioned, you know how it is a small place for lots of population. The remaining land will be mostly high density residential tower or commercial tower, and less public open spaces will be provided, as seen in your animation in perhaps 2100. So what is your thought on the new form of public spaces?
Hi, thank you for your question, Gavin. I'm Gabriel from National University of Singapore. I think one of the things that we tried to do was to create spaces that transforms with the inundation of water into the public areas. And the reason why we chose vertical high density towers is because that would actually allocate more spaces for public areas, even though water has come up into the site itself. So with the high densification of towers, we actually create more spaces that are land-based public areas as well as water-based ones. So with the combination of the two of it, it actually helps to create a new sort of living with water, and also with the old living where we used to be more familiar with landscapes as urban spaces. But in this case, amphibian spaces would then create a new sort of sense of public spaces for the residences of the East Coast region as well. I hope that answers your question.
Thank you.
It seems that you guys are being very efficient with time. So I've been told that we might have time for a second question in these cases. So Hong Kong University, do you have any further questions for University of Singapore?
Yeah, actually, I think there's a situation that rather than only the water level rises, there's also a low tide and high tide within the day. So do you think of any design strategy to also respond to such changes?
We did think of other strategies. Certainly, these three projects are not the only main ones that have been developed through the semester. One of the main master plan strategies was actually creating a dock. And this dock is a multifunctional one where during the high tide, it will become an area for ship circulation to be carried out in the site itself. And when it's low tide, it can actually function as an amphitheater or some sort of a public space for people to venture to and to have a good time there. And also, we also created several instances where the high and low tide actually creates a certain wetland phenomena. For example, my project where the high tides actually brings in the sedimentation of the eroding soil around the mounts, and eventually they will form certain wetlands. So this high tide and low tide phenomenon actually helps to create new land for public amenities to happen.
Thank you very much. Now, University of Melbourne will be asking a question to Hong Kong University.
Hi, I'm Claudia Surik and I'm representing University of Melbourne, and we're asking Hong Kong that in terms of how does the structure relate to the regenerative urbanism and the wider environment?
Charmaine. Yeah, sure. Actually, our studio is kind of developing a new kind of tower typology, which is resilient to the changing environment, due to the extreme climate caused by the global warming. It caused a lot of frequent typhoon, flooding, heavy rain, and extreme temperature. So our studio is kind of thinking about the next generation of architecture in terms of sustainability, resilience, and adaptation. So it is kind of challenge the typical Hong Kong high-rise typology, which is predominant of podium tower configuration. And this studio is kind of think about how do we develop another typology, a new kind of typology, which is resilient to the changing environments in terms of structure, in terms of building system, so that this kind of transformation of architecture could be adaptive to the changing environment through our architectural interventions.
Thank you. Again, it seems we have time for one more question. Claudia from University of Melbourne, do you have any further questions for Hong Kong University?
We've got another question because it's very different here in Australia, in Melbourne especially. To combat the typhoon seasons that you have, would there be an option to be able to bring those towers more inland?
Actually, yes, because this is not actually for the coastal condition, especially for my project, which is resilient to the wind on the top of the tower, and also adaptive to sea level rising at the base of the tower. So actually, the tower intervention could be moved to the inland area, so that it is also resilient to the extremely wind condition. Especially my design is kind of letting the wind and accelerate and allow to funnel through the tower to regenerate renewable energies, and also dissipating the wind effect to the tower.
Thank you very much. So we will move to University of Washington, posing a question to University of Melbourne.
Hi, everyone. I'm Courtney Ross. I'm representing University of Washington. I was really excited to see that there are elements of recreation and education integrated into your proposal. curious if those elements came from a need identified for something like that living in sort of the nearby cities, or do you have a sense for what the demand would be like for those activities?
Yes, I'm Kelly from the University of Melbourne. So our site is like from like 70 kilometers from Melbourne. And the village size is like it hosts like about 300 people. So about the question you mentioning about the demand of people, because the site is mainly like focusing on agriculture. So we were like mainly trying to invite like to build up this connection of like the larger land and to the urban life, and trying to invite people from the city and to appreciate the value of aquifer and the urban farming. And so like for each farmland, we were considering like it has like the communal urban area on the like wetland park. So it would like host the basically like the visitors from main city of like Melbourne.
Thank you. So again, we have slightly more time. So University of Washington, would you like to ask another question to University of Melbourne?
Yeah, I have one other. It might be very specific, and I'm an urban planner, so I don't know a ton about landscape architecture. But I was looking at the waste to energy plant, and I was wondering. I saw that there were inputs coming from the agricultural operation, but I was curious if there were inputs coming also from waste generated in Melbourne or in other areas, or is it exclusively turning the waste coming from the regenerative agriculture operation into something productive?
It mainly deal with the agricultural waste. So for like manure, food residue, and those crop waste. And then those waste will like come through the anaerobic digestion process, like into like it produce like the digestate, which is more nutrient kind of fertilizer for agriculture, and which would like further benefit the agricultural environment.
Thank you. And it seems we still have time for the first ones to pose one more question. So National University of Singapore, would you like to ask another question to University of Washington? Sorry, Clarence, we can't hear you.
Yeah, sorry. So I was informed yesterday that you guys were not architecture students. So may I ask what discipline are you from?
Courtney and I, who are representing UW, are both urban planners.
Urban planners. I see. So I think there is some correlation with architecture. So how do you think your urban planning experience and or urban planning theories, kind of coincide with architecture, and how does that differ from what the works that we kind of did? Yeah.
I can build off of the first question you asked, because I think that ended up being a big success of having a multidisciplinary studio. So we had architects, landscape architects, and urban planners. And of course, Courtney and I, as people who don't design specific facilities and specific structures, that was not our area of contribution. So we had a lot of people who were doing things like that. But we were able to supplement that work and perhaps make it a little more robust in terms of doing economic feasibility, social feasibility. Like I mentioned before, we had done social intervention. So proposing to a community, not just the structure, here you go, try and make it work for you. We really were working to identify needs in the community, wants in the community, make the interventions that other people were designing something that would have a lasting impact on the community.
Thank you, everyone. I think we need to wrap up this session. It was very interesting to hear all your answers, and I'm sure some of those questions will carry on to other other sessions as well. So please stay with us tuned today. And now we'll move on to the Earth, Wind and Fire session that is going to be introduced and moderated by Jeffrey Inaba from UCLA. So please help me welcome Jeffrey, and I'll pass it to you. Thank you.
Thank you so much, Leda. Welcome everyone. It's a pleasure to be able to moderate this next section, which is called Earth, Wind, and Fire. And so the idea of Earth, Wind, and Fire is that we have dealt in this group with disasters that deal with earthquakes, earth-based tremblings, if you will, wind in terms of typhoon, and fire, and specifically with fire, the threats of fire due to climate change. So in this group, we'll have 4 presentations, 2 by UCLA. The first one by UCLA is a postgraduate studio. The second is a Master of Architecture studio. That will be followed by a presentation from Tsinghua University, and then a presentation from University of Tokyo. We're really excited to be able to share these projects in this format, and most importantly, to be able to have students talk to each other, share their projects, and receive input. So with that, we'll start with the first presentation.
As the meeting point between natural and built landscapes, the wild-urban interface constitutes areas at highest risk for destructive and deadly fires. In order to mitigate this risk, we must rethink how these two entities meet, and limit the abrupt delineation between the arbitrary jurisdiction of natural land and urban land. Rather than allowing these territories to meet along a single edge, this proposal reconfigures the built environment in the areas surrounding Paradise, California to create a series of edited edge conditions. The master plan strategy inserts 2 intermediary zones between wild and urban, designated as wild adjusted and urban adjusted. The town plan, reconfigured around shared resources, public lands and year-round activated hubs, aims to foster community as a key ingredient to resilience. As a partial physical barrier, the thresholds will help to slow the spread of fire. But just as importantly, the master plan offers sites to engage the community during times of tranquility and non-emergency, so that recovery after disaster is less daunting. The chosen project node on the eastern periphery of Paradise exemplifies this activity-driven approach, utilizing structures that highlight both UA and WA strategies respectively. The site of our main project is a section of the urban adjusted and wild adjusted zones on the eastern bluff of Paradise, looking out onto the Feather River Valley. The farmers' market takes on a matte condition, sited lightly on the land and transitioning level by level with the slight slope on the top of the hill. Conversely, the wildfire management hub digs into the steep side of the hill, exposing dramatic views throughout the valley and beyond into the surrounding wildlands. Though the two structures operate independently and convey juxtaposing attitudes toward the landscape, the ecology of the site as a whole operates as a single system to facilitate both long-term and short-term resiliency. The planar organization of the farmers' market mediates between the strict 40-foot by 40-foot column grid of the wind field and the slight slope of the landscape. Each floor plate of the structure descends in 5-foot increments, allowing for a high level of visibility across the market. The programmed spaces of the site include an information center, administrative office, sit-down restaurant, security office, eating and seating areas, children's area equipped with solar energy absorbing play structures, and market stalls. The stalls are categorized as produce stalls, prepared food stalls, and flea market stalls. Each of these stall types has slight differences in layout, but all conform to the 20-foot by 20-foot footprint dictated by the subdivision of the column grid. As a transitory site, the market operates through continuous movement. Vendors, customers, goods, architectural components and wind flow all constantly circulate through the space. The orientation of the project emphasizes this aspect, as main walkways cut through the market maximizing east-west directionality. The turbines operate via oscillation of a carbon fiber shell. The resulting kinetic energy is absorbed and converted without transitioning to the structural column below. The community of Paradise uses the space as a recurrent site of socializing, exchange, and play. This initiates the market as an important hub in the civic life of the town. With this relationship established, the market is primed to serve as a site of community resilience in the event of a disaster. Supplies distribution, communal services, and temporary shelter take over the spaces in the aftermath of a major emergency event, wildfire or otherwise. And the flexibility of the architectural system facilitates this transition. The different store types align with different needs of accommodation for varying lengths of time, depending on the magnitude of the event. The open, highly flexible produce and flea market stores can be maximized with beds and storage for short duration stays, while the layout of the prepared food stores are equipped with semi-private sleeping quarters and micro-kitchens for longer stays. The intention of the farmers' market is to demonstrate flexibility, not as a trope often associated with resilience, but as a community-specific strategy in both program and design. The site combines aspects of adaptability in both urban-scale design and small-scale architectural detailing. In this way, the project facilitates a broader understanding of how human activity and natural ecologies can support and benefit each other. Moving further out from the farmers' market following a pedestrian path across the site, visitors to the wildfire management hub and community outlook are greeted with a minimal entry marking the edge of the wild adjusted zone. From the top level, visitors can descend into the building or choose to remain on the rooftop terrace to enjoy views of the valley. The first interior level opens into the lobby space and information center, with adjoining open offices for fire management officials. The lofted level, opposite the main staircase, meets the surface of the fire access road, allowing for easily available storage of firefighting equipment and vehicles. The sunken reading area aims to facilitate casual exchange between community members and officers of the CFMC, PBA, Paradise Fire Department and CAL FIRE, offering freely available information on fire safety, permitting for prescriptive burning, and volunteer opportunities. Descending further into the wild adjusted zone, the building opens out onto the topography of the hillside, confronting visitors with a physical experience of traversing the landscape. At this level, open community gathering space offers flexibility in program and function, from large-scale information sessions to small group trainings. The orientation of the building allows for unobstructed views of the surrounding wildlands, and sets the stage for community members to witness changes in the landscape over time. The structure itself acts as a threshold, functioning as a main hub for a larger network of fire management officials and administrators by providing access into the wildlands. The hub also offers the broader community of Paradise a space to appreciate and learn from their natural surroundings, allowing them to reflect on their own existence and daily activities within the greater context of the larger ecosystem.
Wildfires are destroying California cities, and natural and human factors are causing these massive fires. When natural and human conditions overlap as they do in the wild and urban interface, they can either dramatically increase damage caused by fire or, as we believe, significantly decrease damage. In Sonoma County, the story has been one of increasing damage, and urban sprawl in the WUI is a primary contributing factor. 30% of the region's housing stock is located in the WUI, and it is the fastest growing zone type in the US. Planning in the WUI is no longer a marginal phenomenon, but it should become a major focus of urban design through an approach that applies strategic thinking. And this brings us to agriculture, and in particular the wine industry. Being the largest interface of human and nature, urban and wildland, agriculture is a major industry and economic engine in California. Vineyards are also an effective fire break due to their regular irrigation system and their general location between urbanized area and wilderness. This generates the paradox that, while vineyards are damaged by wildfires, they can protect the region from catastrophic fire events. The smart planning and expansion of vineyards as a fire break will reduce the destruction from the recurring fires in these inherent vulnerable regions. We propose a public and private sector alliance in which winery planning reduces the spread of wildfire, reduces the state of fire suppression cost, and safeguards and grows the region's economy. Overlapping 20 major fires with local vineyards reveals effectiveness of vineyards as fire break. We are focusing on an area close to urbanized development, which will likely sprawl in following decades, and that is currently vulnerable to wildfires. In 2020, the glass fire burned this area, causing more than $200 million in loss to wine industry. We first proposed several networks which aim to decrease the chance of ignitions and slow the spread of wildfire. Overlapping these preparedness networks with past fires, we selected several critical areas for our proposal. This site is between Walland and a Sonoma community that is separated by Sonoma Highway. It consists of public agency land and private wineries. The glass fire showed that the vineyards play a crucial role in stopping its spread. By setting up here, we believe we can improve the region's resistance to recurrent fires. The first step is to lease public land to winemakers in a high-risk zone upwind from public agencies. This will generate revenue for the county as well as no-cost fire management where there is currently little fire management, while supporting early-stage wine businesses with low land cost. Bike paths extend from existing roads to expand tourism by enabling tourists to enjoy the vineyard. At the same time, they serve as fire evacuation routes. Tourism activities, which benefit the local economy, are also important as an opportunity to educate people about wildfire and agriculture. As a form of climate change urbanism, we integrated winemaking, fire protection, and tourism into each building complex. In addition to responding to the effects of climate change, the design reduces factors that contribute to climate change as part of our fire prevention measures. Irrigation and water harvesting system improve water management while creating patchy wet areas that slow fire. Also, plant cover cropping in the vineyards sequester carbon while enriching soil fertility. Wildfire threats, winemaking, and tourism are all at high points during the same season, a triple threat to lives and the regional economy. The positive correlation between wildfires and winemaking is reflected to the local population. Based on these variations, we divided programs into permanent and temporary ones. We envision our proposal to protect cities from fire and gradually decrease the occurrence and spread of wildfires. As this virtuous cycle repeats year after year, new best practices can be introduced to improve fire resistance and wine quality and production. Within the design, spaces are changeable and serve double duty, geared to wine production and fire resistance and response. Their profits and overall benefits are shared by the public and private sectors as a way to support each other functionally and financially. In general, the public unit holds seasonal worker houses, shareable wine facilities, and temporary fire stations, while the private unit holds the rest of the wine facilities and temporary shelter. Each of these spaces show flexibility during each season, shifting its usage time to time between winery, fire-related facilities, and public spaces. For the architectural composition, first each program is laid out within home ignition zone distance integrated within the vineyard. And in between spaces, various hierarchies of courtyard become a part of main circulation for wineries, temporary shelters, and seasonal houses, which contain outdoor public activity area as well as outdoor wine processing spaces. Also, the view lines crossing the structures allow visitors and users to open up their view of the overall scenery. And these L-shaped roofs cover the program spaces and courtyards, providing shade below. These metal roofs have steeper angle to the north side, which will decrease its surface facing Diablo wind with ember storm. Also, the opening on the top of the roof will allow air circulation inside with ventry effect. These roofs can let the rainwater flow naturally along the pattern of the roof and its angle to collect them at the bottom. For the openings that are created by lifting up the part of the roof, its surfaces are covered with mesh, so that it is translucent while it can still protect the inside space from ember storm. Also, the mesh facade will collect the water from the fog early morning in the region, creating a waterway surrounding each courtyard with atmospheric effect. And finally, all these features integrated with the overall scenery in Sonoma Valley, leading to a new lifestyle in the region.
Hello everyone, I'm Zhang Xuan from Tsinghua University in Beijing. I'm so happy and honored to be here on behalf of my classmates to introduce our studio to all of you. The theme of our studio is Disaster Risk Reduction and Resilience of Shaji Tibetan Village, Lixian County, Sichuan Province of China. This course is for the first semester students of Master of Architecture. Our studio lasts for 16 weeks. Directed by Professor Xu and Professor Luo and Wantie Wang Wanlin. We have 12 students which were divided into 5 groups to work on different research topics. In the first 3 weeks, we went to Shaji to research local conditions. In week 8 and week 12, we held 2 midterm reviews, and we delivered the final proposals at the end of week 16. Now I will share some details. Shaji village is located in Li County, the west of Sichuan province. It's at a high altitude with grand sites of mountains and valleys. The tourism industry in Li County is also booming because of its natural scenery. Another important background is that Shaji is near the epicenter of the 2008 Wenchuan earthquake, and almost 100% of the houses were damaged. There are some remaining buildings which are as memory of history. When we arrived there, we first measured and worked on the drawings of the buildings on the site, which provided the foundation for the later design. After that, we conducted a survey on the village as a whole and mastered the basic situation and social relations of the villagers. Besides, the village culture of Shaji caught our interest. It is a combination of Tibetan and Cheng ethnic cultures. Here are some scenes in their daily life. So it's important for them to continue their culture and traditions. After discussion and analysis, the whole group reached some consensus. First of all, we should protect the village culture with Shaji characteristics, because they are unique and full of vitality. Second, we must upgrade the village infrastructure so that it is less vulnerable to earthquakes. Finally, we hope that Shaji village will be able to make sustainable development at economic, social, and environmental levels. Based on the consensus, we proposed 5 different plans in the balance of the key social, economic, and environmental benefits. The 5 proposals will be analyzed in the 3 types as follows. From the point of view of industrial upgrading, the proposal of Shaji Liquor Village makes use of plant industries. They want to promote the revitalization of the village and to strengthen the vitality of the village life. Also based on economic benefits, There is another proposal of Shaji Resort Village. They dug out the little points of village life that are attractive to the urban population, and then connected them into a tourism belt with the mark of Shaji. Therefore, the renewal of ethnic villages can be realized. From the perspective of social benefits, we also propose different paths for Shaji's development. The proposal of Shaji Eco Museum protected the ethnic and settlement culture of Shaji by means of experimental tourism. After reflecting on relevant cases at home and abroad, it proposed an innovative mode involving an operating institutions. The humanistic Shaji homeland starts from the infrastructure of the village itself. They strive to create more social values and industrial development potential, while improving the life of the villagers. In this way, they can realize the protection of the original culture of the village. The last proposal of hiking Shaji focuses on the larger geographical environment. They take the advantage of the high mountain and valley area where Shaji is located, and they take the village as a node in the western Sichuan hiking route. This proposal addresses the renewal and development of the local area from the perspective of the overall environment. Because time is limited, if you want to know more details, welcome to look at our board and discuss with us. Thank you.
This is the University of Tokyo, and our topic is pre-disaster reconstruction design for resilience in a city with diverse residents. First, as a background, in Tokyo, there are many areas containing totally different types of houses, such as detached houses, apartment houses, and so on. Therefore, these areas may contain different types of residents. And our research focuses on pre-disaster recovery design, since we think when a disaster occurs, different types of residents will behave in different ways, and a recovery plan is necessary to deal with this before the disaster. And we chose Echijima area in Tohoku, Tokyo as the site, since it contains residents of all different attributes such as age and incomes and so on.
Next, I talk about disaster scenario. There are two natural hazards expected in Tokyo area, earthquake and flood by typhoon. In Echijima area, the risks due to an earthquake are low compared with the other areas. As for a flood, inundation height and duration time are also relatively low. However, when we think about the damage of infrastructure caused by earthquake, the damage by flood will be augmented, because the failure of sluice gates and drainage system will cause more severe flood than expected. In summary, the risk of an earthquake alone or a flood alone is relatively low in Echijima area. However, in the case of a flood right after an earthquake, the damage can be serious due to failed infrastructure. In order to prepare for that kind of risks, we assume two consecutive disasters. First, an earthquake of magnitude 7.0 happens in Tokyo area, which are expected to occur sometime in the next 30 years with a 70% probability. Then, 1 year after the earthquake, a flood disaster by typhoon strikes Tokyo. We plan and design recovery process of Echijima area after these two disasters.
As we mentioned in the first part, we focused on different types of residents. Echijima area can be classified by these three types: detached houses in the blue area, public housings in the yellow area, high-rise apartments in the orange area. We estimated main residents of each types by their characteristics. First is detached house area. In this area, as you can see in this picture, there are many houses which has many types of shops or offices in the first floor. So we can say that this area also shows their local economies. Public housings are mainly for senior citizens and families with small children, whom are low-income earners. High-rise apartments are residents for high-income earners. We presume that residents are mainly the middle-aged couples.
Following the residential type just mentioned, we will briefly summarize possible damages and situations after a disaster. First, right after an earthquake, both residents of public housing and high-rise apartments may move out from the region and evacuate. Then, after the flooding occurs, inundation will destroy low-rise habitations. As a result, residents of public housing cannot return home anymore. As for high-rise apartments, property values will possibly decline and lead to deterioration of housing environment. On the other hand, the damage due to earthquake may become serious along land use for detached houses. The area expected to have relatively a higher risk of collapse than the average of Tohoku, and these kind of low-rise housing are also at risk of inundation, since the area and below sea level area overlap for most part, as you can see in this map. So, if an earthquake breaks down sluice gates and levees, the flood damage is serious along the area. As a result, various occupations such as printing and design businesses, restaurants, and shopping will move out. These factors will cause decay of local economy and convenience in the region. In these ways, the damage to detached houses will possibly affect the residents in public housing and apartment as well, and lead to a vicious cycle in the region. The population who moved out due to the earthquake will increase after the flooding, and the city will lose its vitality from the retreat of various urban functions. In addition, as seen in the case of New Orleans, 30% of the population may move out even if the damage is minor. In other words, from a long-term perspective, the deterioration of the housing environment and the aging of the population may lead to a city that cannot be reconstructed. Therefore, we must consider integrated construction processes among the three residential types. Otherwise, all of the inhabitants in the region will possibly move out.
The idea of pre-construction is mainly based on 2 points. One is response, and the other is improvement. If we plan, or at least discuss the ideal image of the future city, it will help the reconstruction process and even solve the problems entrenched in the area. If we do nothing before disaster and the current urban planning of reconstruction continues, only the government will be able to supply the reconstruction public houses in the detached house area, but they are to be inundated and cause withdrawal of small owners. We can prepare for disaster in advance by organizing cooperation between public housing area in the western part of the world and the damaged houses located on the lower ground. They can restore their lives and businesses from the reconstruction platform in the public housing area and have little difficulty in returning to the area. After disaster, small buildings can be reconstructed as to have raising structure. It's based on the cultural and historical background of water transportation of the area, Kashi. Few of them remain. We can revitalize them to fit into the modern structure, not only to make the city resilient to the flooding, but also to foster attribution and affection to the city, leading the citizens to understand the characteristic and the risk of the area, and attract people as well. With those discussion on the cooperation scheme and design process in advance of the disaster, we can achieve quick recovery and improvement, and it recursively strengthen the resilience of the city. Thank you.
The project The City Seed, designed by Esteban Lee, envisions a new urban morphology of subterranean dwellings and 3D-printed earthen architecture. The City Seed, reinventing human habitation at the wildlife-urban interface through combinatory urban morphologies. A project by Esteban Lee under the instruction of Ronald Rael. The City Seed project is a speculative proposal for the redevelopment of Paradise, California, and the envisioning of a new paradigm for human habitation at the wildland-urban interface. The project's premise is to establish economic and fire resiliency in Paradise, to provide fire-resistant shelter post-fire disaster, and to dramatically re-envision urban morphology and materiality. With the threat of fire disaster growing year by year in Northern California, it is critical that fire-resistant materials and urban planning be utilized to minimize the burning of our built environment and to build stronger, more resilient communities. In 2018, Paradise was struck by the Camp Fire, one of the deadliest forest fires in California history, which led to a tremendous loss of life. Thousands of homes and commercial structures were destroyed due to the fire, leading to a huge exodus from Paradise in the aftermath. The City Seed project includes the design of several buildings situated in a new master plan for Paradise. The plan will phase in the construction of 4 multi-use communities, which will provide Paradise with fire-resistant homes and public structures. The central concept of the City Seed project is taken from the heart of the problem of wildfires, and from the beginning of any forest, the seed. As if planting a seed for the growth of a new forest city, this project looks into the future of how new homes and shelter can be constructed with fire-resistant materials and fire-preventative planning strategies. The city uses 3D printed earthen construction, terraforming, and troglodyte subterranean dwellings as a code or DNA for future growth. This city will use the refuse of the 2018 campfire as a resource for new construction. The planning of a series of tree farms and managed natural forests in adjacent areas of the burnt city will provide future building materials and could one day become a future site for earthen construction. Increased density of residential, commercial, civic, and recreational functions minimizes the amount of dispersed rural dwellings, which often contribute to bad forest ecology and risk of fire damage. While the City Seed project is primarily new construction, a complex palimpsest of new and old is produced by preserving major road networks and large portions of central Paradise. The primary fire-resistant measures of the city lie in its excavation of earth and subterranean spaces. The primary residential component of the project is its grid of homes dispersed across the site in the form of subterranean courtyard dwellings. Their central courtyards act as a central circulation space and give residents the ability to take shelter under the earth in case of fire. As another key fire-resistant measure, the combinatory form provides space for new water reservoirs, which have a dual function as park amenities and as water storage for use in putting out fires. The project's combinatory formal strategy is explored through various architectural models at several scales and produces a multiplicity of microclimates and spatial conditions throughout the city. In the generation of these forms, a complex aggregation of various prototypes is achieved through parametric randomization of rotation, scale, and frequency. A rich underlying system is produced by the Boolean relationship between these objects to each other and to the origin surface or field condition. The introduction of a variety of formal prototypes also allows for the negotiation and incorporation of water reservoirs, public recreation spaces, and tree farms into the urban landscape. The project critically reconsiders the ground plane as a hybrid of synthetic and natural landscapes. The courtyard prototype is the primary residential component of the development. The network of single-family homes creates an interconnected field across the site. Each home benefits from passive heating and cooling thanks to the temperature of the earth. Terracing and circulation down to the courtyard home maximizes southern exposure and increases availability to natural light. Each home is radially planned around a central garden and courtyard. The spaces deeper in the earth act as shelters from fire and receive natural light from skylights. These subterranean spaces would be constructed with 3D printed earth, concrete, and small diameter timber framing. The excavated earth gathered from each home would be saved as a resource for constructing other buildings on the site. The final prototype explored by this project is the ring prototype, which can be seen across the site at the location of several water reservoirs. Water is contained by this massive outer concrete ring. Some of these small lakes will be available for public use as amenities and parks, while others will be reserved for firefighting purposes. The ring typology seen in this physical model shows how these forms can be segmented and constructed as buildings. These extruded building forms function as educational or medical facilities and are connected to other commercial and residential areas through public metro systems. The slanted floor plates of this building accommodate auditoriums and lecture halls. The primary horizontal circulation at the core of the building connects several building chunks as sky bridges, while the vertical circulation is achieved through the addition of a series of rectilinear cores. Seen in this physical model are the additive mound building types aggregated across the site. These building types take on a variety of construction techniques and sectional properties. These prototypes are typically planned as multifunctional buildings across the site, housing commercial, civic, and multifamily residential functions. The mound form is designed as a green hill with subterranean troglodyte spaces on the interior. Its primary vertical circulation is located at its core, with horizontal circulation weaving in and out of the hill at its circumference. Large atriums and skylights allow light into the interior of the mound. By maximizing the earthen exterior and minimizing exterior facades, this building becomes protected from potential fires. The third and final construction type would be a free-plan tower with a non-structural glass and ceramic skin. Its primary structure is a small-diameter timber structural frame and a vertical core. The ceramic facade is sourced from local clay and provides the building with shading and fire protection as a fire-resistant and anti-corrosive material.
Hi, everyone. Nice to see you again. We're going to replay the first UCLA video. We understand that there was a technical glitch with that. So we'll see that again. It's actually a good thing because the last video you saw by the UC Berkeley team deals with this very same site as the team that we're going to see first. So you'll see some relationships of the area and understand the patterns of growth and proposed development for the two. So with that, I think we're going to play it now, and then we'll have questions afterwards.
As the meeting point between natural and built landscapes, the wild-urban interface constitutes areas at highest risk for destructive and deadly fires. In order to mitigate this risk, we must rethink how these two entities meet, and limit the abrupt delineation between the arbitrary jurisdiction of natural land and urban land, rather than allowing these territories. As the meeting point between natural and built landscapes, the wild-urban interface constitutes areas at highest risk for destructive and deadly fires. In order to mitigate this risk, we must rethink how these two entities meet, and limit the abrupt delineation between the arbitrary jurisdiction of natural land and urban land, rather than allowing these territories to meet along a single edge. This proposal reconfigures the built environment in the areas surrounding Paradise, California to create a series of edited edge conditions. The master plan strategy inserts two intermediary zones between wild and urban, designated as wild adjusted and urban adjusted. The town plan, reconfigured around shared resources, public lands and year-round activated hubs, aims to foster community as a key ingredient to resilience. As a partial physical barrier, the thresholds will help to slow the spread of fire. But just as importantly, the master plan offers sites to engage the community during times of tranquility and non-emergency, so that recovery after disaster is less daunting. The chosen project node on the eastern periphery of Paradise exemplifies this activity-driven approach, utilizing structures that highlight both UA and WA strategies respectively. The site of our main project is a section of the urban adjusted and wild adjusted zones on the eastern bluff of Paradise, looking out onto the Feather River Valley. The farmers market takes on a matte condition, sited lightly on the land and transitioning level by level with the slight slope on the top of the hill. Conversely, the wildfire management hub digs into the steep side of the hill, exposing dramatic views throughout the valley and beyond into the surrounding wildlands. Though the two structures operate independently and convey juxtaposing attitudes toward the landscape, the ecology of the site as a whole operates as a single system to facilitate both long-term and short-term resiliency. The planar organization of the farmers' market mediates between the strict 40-foot by 40-foot column grid of the windfield and the slight slope of the landscape. Each floor plate of the structure descends in 5-foot increments, allowing for a high level of visibility across the market. The programmed spaces of the site include an information center, administrative office, sit-down restaurant, security office, eating and seating areas, children's area equipped with solar energy absorbing play structures, and market stalls. The stalls are categorized as produce stalls, prepared food stalls, and flea market stalls. Each of these stall types has slight differences in layout, but all conform to the 20-foot by 20-foot footprint dictated by the subdivision of the column grid. As a transitory site, the market operates through continuous movement. Vendors, customers, goods, architectural components and wind flow all constantly circulate through the space. The orientation of the project emphasizes this aspect, as main walkways cut through the market maximizing east-west directionality. The turbines operate via oscillation of a carbon fiber shell. The resulting kinetic energy is absorbed and converted without transitioning to the structural column below. The community of Paradise uses the space as a recurrent site of socializing, exchange, and play. This initiates the market as an important hub in the civic life of the town. With this relationship established, the market is primed to serve as a site of community resilience in the event of a disaster. Supplies distribution, communal services, and temporary shelter take over the spaces in the aftermath of a major emergency event, wildfire or otherwise. And the flexibility of the architectural system facilitates this transition. The different stall types align with different needs of accommodation for varying lengths of time, depending on the magnitude of the event. The open, highly flexible produce and flea market stalls can be maximized with beds and storage for short duration stays, while the layout of the prepared food stalls are equipped with semi-private sleeping quarters and micro-kitchens for longer stays. The intention of the farmers' market is to demonstrate flexibility, not as a trope often associated with resilience, but as a community-specific strategy in both program and design. The site combines aspects of adaptability in both urban-scale design and small-scale architectural detailing. In this way, the project facilitates a broader understanding of how human activity and natural ecologies can support and benefit each other. Moving further out from the farmers' market following a pedestrian path across the site, visitors to the wildfire management hub and community outlook are greeted with a minimal entry marking the edge of the wild adjusted zone. From the top level, visitors can descend into the building or choose to remain on the rooftop terrace to enjoy views of the valley. The first interior level opens into the lobby space and information center, with adjoining open offices for fire management officials. The lofted level, opposite the main staircase, meets the surface of the fire access road, allowing for easily available storage of firefighting equipment and vehicles. The sunken reading area aims to facilitate casual exchange between community members and officers of the CFMC, PBA, Paradise Fire Department and CAL FIRE, offering freely available information on fire safety, permitting for prescriptive burning, and volunteer opportunities. Descending further into the wild adjusted zone, the building opens out onto the topography of the hillside, confronting visitors with a physical experience of traversing the landscape. At this level, open community gathering space offers flexibility in program and function, from large-scale information sessions to small group trainings. The orientation of the building allows for unobstructed views of the surrounding wildlands, and sets the stage for community members to witness changes in the landscape over time. The structure itself acts as a threshold, functioning as a main hub for a larger network of fire management officials and administrators by providing access into the wildlands. The hub also offers the broader community of Paradise a space to appreciate and learn from their natural surroundings, allowing them to reflect on their own existence and daily activities within the greater context of the larger ecosystem.
Thank you so much, guys, for the amazing presentations. They're really, really well edited and so well put together as storytelling presentations of your projects. So we're going to move now to the question and answer phase of this session. So the first question will be by Tsinghua University to the first UCLA group, the video that you just saw.
Hello. I think the site strategy of this design is very great. What is the role and attitude of the building itself in balancing disaster prevention and daily life? Can you talk about the consideration of structure, form, path, and material? I noticed that the market is fabricated. Why is it such a form? Why is the modulus of 40 foot used? And that's my question.
Great, thank you. Hi, I'm Amy. So the conceptual framework for the project as a whole is really about integrating the natural ecological realities of the landscape into the daily life of residents of the town. So the two sites do that in different ways. For example, that 40 foot by 40 foot grid of the farmers market is really firstly dictated by the bladeless wind turbine field, which is about capturing the and harnessing the power of the seasonal Diablo winds in that area. And then on top of that, the architecture for that space really allows for a high degree of flexibility and kind of transitioning depending on the need of a fire event.
Great. We have time for another question. I think before you do, one thing that you brought up, Amy, that's super interesting is the idea that you would actually become more aware of the energy generation during the heightened fire season because that correlates to when the Diablo winds would occur. That's really fascinating. So Yingpei, would you like to ask another question?
I want to ask, what do you see the relationship between disaster and daily life? Is it? And so your strategy is the flexibility and the access to the wildfire. Is it?
Mm-hmm. Yeah, I think our approach to resiliency was really kind of two-part in that it's kind of short-term event-based, so being able to respond to a disaster right away and quickly, but then also, as Jeffrey kind of mentioned, shaping the kind of everyday life of the people and having that be more of a long-term resiliency goal, and then allowing people and the town to be able to have a framework for higher resiliency just year long without an event necessarily.
Yes, I like this. I like this strategy.
Yeah. I mean, I think there are a lot of commonalities between that approach, Amy, and in fact the Tsinghua team. So it's fascinating, the idea that everyday life is integrated into an awareness of resilience. Okay, now we're going to switch it over to the second UCLA team, which will ask a question of the Tsinghua group.
Hello, I'm Regan from UCLA, and thank you so much for the presentation. I found it quite amazing in your project that you really tried to reflect the current condition and needs of the actual residents into your project. So we have some questions about the project Humanistic Homeland by Group 4. So the first question is, what does the black loop of the master plan refers to, and how does it shape the location? How does its shape and location consider culture and earthquake?
For the first question, the black loop refers to the driveway around Shaji village. Since the village is on a steep slope of the mountain, there is only one route of traffic way. And our group decided to do some infrastructure designs near the road to make sure that farmers can transport crops and vegetables more conveniently and to evacuate when there is a geological disaster. And for the second question, for example, there's a dwelling which only one layer of stone wall was left after the earthquake. We try to retain all the ruins and add steel structure and second floor and roof to turn it into a Tibetan weaving and embroidery workshop. We use a modern spatial language to reproduce the space of central column fireplace. In Chinese, it's 中柱火堂, which means the living space in family and neighbors in their Aboriginal culture. We hope that the villagers can restart a happy public life and daily life after the earthquake. So we create a series of neighborhood unit space for women, old people, and children, various people, and to facilitate daily communication and cooperation.
Fantastic.
Yes,
Please.
I think it's important to reproduce a place for them to have daily life, and we also encourage them to have some festival and some activities in some public squares. Yes.
Thank you so much, Yingpei. Really wonderful,
Thank you.
super informative, and it spells out a lot of the things that were described in the video with more dimensions. So really wonderful. Okay, we're gonna hear a question from University of Tokyo to the second UCLA group.
Hello, I'm Asma, and I'm representing the Tokyo University. First, thank you for your presentation. Really great concepts and architectural design to increase fire protection while developing other industries and sectors. My question is about using vineyards as a barrier against fire spreading. With climate change and the likelihood of a fire happening 2 years in a row is not impossible, how are you planning to deal with a recurrent fire disaster while using vineyards that are already damaged from previous fires? Thank you.
Hi, I'm Cheng from UCLA, and thanks for this question that mentioned the core strategy of our project. So first of all, the major reason for using Vineyard as a fire break is due to its location that is in between city and wildland. And also this place is where population growing fast, while especially vulnerable to the wildfire at the same time. So as shown in our network diagram, the areas we select are the places with existing vineyards. So speaking of appropriateness for growing vineyard there, the conditions have already been set and selected. And this preparedness network like fire fuel management, location of water bodies, or buffer zones we set are aiming to largely decrease the chance of ignitions. Therefore, it is true that some part of them might be still inevitable damaged by fires. And this kind of area can be put into the post-fire recovery activities and make it more resistant in the following years. But still, comparing to the damage to the whole city, it's still worthy in our perspective.
Great. I think we have time for one quick question if you want to ask a second question, Asma.
Yeah, sure.
Okay.
For your master plan strategy proposal, you mentioned preparedness networks and pacifiers aimed to decrease the chance of ignition. So I was wondering, can you explain what these preparedness networks are?
Sure. So this kind of preparedness network, they are not really building something there, but kind of more like to a management, like keeping cleanliness between utility lines or residential area that from vegetation because they cause the fire spreading so quick. So, or we taking the location of water bodies because it's easily to cause excessive runoff in the post-fire period. So we do not encourage people to build here. So we set this kind of network first. So it will help us to decrease the chance of ignitions.
Fantastic. Thank you, Asma and Yenchen. So now we'll hear a question from UC Berkeley to University of Tokyo.
Hi guys, so I'm Esteban Lee, here with UC Berkeley. So I just wanted to say I was really impressed with Tokyo's work today, and I admired all the detailed research you guys had done before, prior to your proposal to understand the site and the risks of the proposed or the envisioned disasters. So I could see that the information was already really useful or could be useful to jumpstart the city's understanding of the local risk and also to start the what you call the pre-reconstruction discussions. And I was just wondering if you had contacted any local officials or organizations already, and if not, how could the studio get involved locally? Thank you.
Hi, thank you for your question. And this is Tiffany from the University of Tokyo. And regarding the interactions between our studio and the authorities, in fact, we are doing some communications to some extent, but I think it is still far not sufficient because the construction plan was mostly led by the authorities and the governments in Japan. So I think it is really important to really interact with the authorities if we really want to make some changes in the plans and the constructions after the disaster or before the disaster. So I think, yes, what you are saying really makes sense. And that is what we are really trying to do from now on. And yes. And that's my answer. Is it okay?
Yeah, thank you.
Thank you.
Thank you, Tiffany. I think it was really one of the most brilliant concepts of this group is the idea of pre-disaster recovery. And I think we all gained a lot from that as a notion. So thank you so much for that. So Amy, your question to Esteban.
Yeah, hi. Thank you so much, Esteban. It was really interesting to see a completely different kind of approach taken at the same site of Paradise. And I was wondering if you could talk a little bit more about how you derive the form of each cluster. The video describes the kind of parametric randomization of the component prototypes, but I'm curious to hear more about how you imagine those nodes functioning as either kind of a collective singular network or more as autonomous hubs that serve to kind of decentralize the town, and then how the form kind of fits into that strategy.
Thank you. Yeah, thank you. That's a really great question. So I guess I envision the various developments as kind of semi-autonomous hubs. So they're trying to negotiate the construction and acquisition of their building materials locally and also use those resources to aid in the fire mitigation independently. And then definitely formally, some of the influences were heavily derived from the work of Tom Main, but we felt that this formal strategy really lended itself to emphasize, through its emphasis of like the surface and the earth-oriented urban form, that it could allow us to develop fire-resistant dwellings. So kind of how you talked about, based on our video, the exploration of the parametric randomization of the forms allowed for the organic introduction of fire-resistant building types, such as you saw the subterranean residential dwellings, and then also the dispersed water reservoirs, and also the 3D printed mounds, which all of them are trying to utilize fire-resistant strategies. And then additionally, the form was driven by the desire to create a variety of urban microclimates, so like pedestrian, recreational, and work environments.
Terrific, terrific. Great, guys. I hope that this is the start of a a conversation, not the end of one, that you guys will be able to talk with one another and exchange notes into the summer. Thank you again for your presentations. And we're going to turn it over to Professor Roberto Morris from Pontifical Catholic University of Chile. And he'll be the moderator for the next panel, which will be multi-hazard disasters. Thank you again, everyone. Take care.
Thank you, Jeffrey. Hi, everybody. In this third panel of multi-hazard, we have 4 universities: the Tohoku University, the National University of Singapore, the National Cheng University of Taiwan, and the Pontifical Catholic University of Chile. The Tohoku University has been working in the town of Zurich, which was very affected by the 2011 Tohoku Great Earthquake. They had been working in a reconstruction strategy of local festival as a disaster mitigation, and how the community can be working in a disaster mitigation culture. In the case of National University of Singapore, they had the studio called The Forest City, exploring symbiosis and self-sufficiency as part of the strategies to face climate change, carbon emission, and urbanization. In the case of National Cheng University, they have been working in the Kiju district. Is an area has been affected by typhoons and landslides, where strong waves has been creating coastline erosion. Because of that, the government has been building artificial berms to protect the oyster shellfish industry. They had been working in the integration, the ecological system and human activities. In the case of our university, the Pontifical Catholic University of Chile, we had the studio called Multi-Hazard Santiago. It's talking about the underlying factors for resilience assessment and integrated planning and design. This is a series of undergraduate research studios. They are young students in where it's the first time they are facing research. The course is mainly focused on territorial analysis, how they can identify underlying risk factors for be considered in future projects. Now we will start with the first video of Tohoku University.
Welcome everyone. This project was made for the Urban and Architecture Design course at Tohoku University under ArcDR3, Architecture and Urban Design for Disaster Risk Reduction and Resilience Initiative. We were called through 2 stages to work in groups on 3 different comparative sites located on the coast of the Tohoku region in multi-hazard conditions for research and design proposals. The sites are Sendai Arhama District, Marumori Town, and Uriage District, on which the presentation will focus. Our intervention focused on Uriage, an eastern coastal district of the Tohoku region, which was strongly affected by the 2011 Great East Japan earthquake, and to respond to the aims of ArcDR3, we had to establish methods of design leading to a strategy of resilience for Uriage in order to limit the damages of natural disasters. Therefore, a multi-hazard assessment that would take into account the various risks and conditions of the Tohoku region was required. Uriage benefited from diverse and rich ecosystems that together formed the base of the landscape, the routing activities, and the cultural and social specificities of the area. Subsequently, the risk of damage is not only geographic or human, it is also social, cultural, economic, and urbanistic, since all the elements of a city are affected at the time of the disaster. After the earthquake, the reconstruction of Uriage advocated land readjustment for the residential area and a review of the allocation of urban zones according to the corresponding disaster hazard level, the geographical characteristics, and the natural environmental potentials. However, if one goes beyond the pragmatic aspect of post-disaster response, relying on structural damage prevention, we quickly realized that the memory of how Uriage's people should react to large-scale disasters was lost even before the 2011 earthquake, which in part resulted in many casualties. Therefore, ERS, or Evolutionary Regenerative System, deployment program had to be built upon triggering awareness, and then is defined around the concept of disaster culture community, where the term disaster culture refers to the culture of acquiring, accumulating, passing on, and utilizing knowledge about disasters. The point is, the implementation of disaster culture as notion nurtured in daily life, and so it is as a concept that cannot be physically destroyed by disaster. We set a higher level concept to position the disaster culture community as a three-dimensional network that plays a role in connecting four layers that are geographical potential, ecological potential, social potential, and disaster prevention potential. To be effective, the ERS in Yoriage will be based on 6 manifesto points that interact within a process of interdependent deployment of natural and human systems. These manifestos are: first, a fair promoting Yoriage; 2, gaps that both bridge; 3, linear festival space; 4, mobile unit network; 5, minor subsistence lure and update; 6, community strengthened by beekeeping. These manifesto constitute the regeneration of the rich ecosystem that forms the original landscape of Yoriage, and at the same time, it will serve as a green infrastructure to enhance resilience to disasters. A multi-hazard and resilient design should be valid for long-term future perspectives, but the Great East Japan earthquake exposes the vulnerability of disaster prevention measures. Then, as the city keeps moving and advancing, rebuilding flow by the disaster culture community would grow along the future development of the place and the population through a resilient timeline beyond 2050. As an evolutionary and regenerative process in any city that is shrinking, it will keep existing and become the guide for ulterior disasters mitigation strategies. To realize the aim of regenerative disaster culture community, we put in place a connected city design strategy aware of the necessity to take flexible measures capable of treating multi-hazardous situations. For that, we sorted out the weak connections with the surrounding areas inherited from the current urban structure and likened them to threads that can be knitted together and then used for disaster prevention, evacuation, and regeneration. For this knitted city, weaving together areas that transcend the regional framework draws on the expansion of the city and overlapping of systems to enhance situational resilience. These 11 elements of threads would be deployed within a three-system organization where the interdependence and complementarity of systems is activated thanks to the disaster culture community, and each system is driven by a key potential of the city that serves simultaneously different threads. System 1 announced under the manifest utilizing water networks as a tool to heal the memory, implement industrial regeneration and create productive landscape. Focus on water drainage, which is a key point in Yoriage. Previously, water was seen as an element of damage. It is time to make it an element of benefit and reissue. Then System 1 comes to redefine the collectively rejected coastal zone by promoting new activities of aquaponics and aquaculture, paired with traditional activities of fishing and transformation of fishing products. These also constitute a clue to manage the storage, distribution, purification, and recycling of water needed for disaster solutions. And the use of high wooden towers would mark the different panoramas besides playing the role of potential evacuation spaces while offering singular sightseeing experiences for a new image of Yoriage that permit a new cultural attraction and knowledge about the area that does not revolve solely around disaster management. As mentioned before, the reactions to be taken in the event of natural disaster and the immediate emergency of evacuation have gradually been omitted to Yoriage, assuming to be safe, in a new town where reconstruction projects have been completed. It is necessary to have an evacuation plan that is easy to understand and familiar to everyone in daily life, inspired by the plant resources and the presence of bees in Yoriage. System 2 proposes the formation of a network of green corridors of endemic flowers, which are nectar plants, throughout the area to visualize the evacuation routes. The green corridors will be managed by local neighborhood associations and businesses and will be positioned as green infrastructure shared by the community. In addition, beekeeping as a newly established activity by the people from the coastal areas to the inland areas will use the set up hives as landmarks for hikers. Then System 2 emphasize on creating a biodiversity and a collective natural atmosphere serving as landmarks for evacuation routes. As for System 3, it comes from the observation that although disaster prevention plazas and pocket parks were planned as part of the last reconstruction project, there are few examples of their effective use on a daily basis. So it proposes a festival as a disaster culture that overlaps the festival of Ohamaori in Yoriage with a disaster culture by planning the linkage of the plaza place. This would be made through the introduction of temporary units as a way to utilize the plaza place. The unit is designed to be easily constructed and transported by the general public, making it an adaptive solution. During normal times, these units can be stocked as buildings and furniture in inland spaces to encourage active use, while in the event of a disaster, they can be transported to evacuation centers to support evacuees. Furthermore, this proposal endorses an aspect of disaster prevention education in which citizens can learn how to respond after a disaster by being involved in this process. Finally, as these three systems expand, overlap, and interweave, exceeding even the urban planning boundaries of UCLA, the weak and vast territorio will enhance resilience against unexpected disasters while preserving the culture and landscape that have been nurtured throughout its history. Thank you for your attention.
For our studio, we will start off with research on climate-related disasters, followed by possible solutions to tackle climate issues, and lastly, apply the solutions to our master plan. The world climate is changing. The irreversible departure from the country's old climate has been coined as climate departure, caused by increased greenhouse emission. Climate departure poses a threat to both humans and other living creatures on the Earth. Singapore is among the first few countries will experience the impact of climate departure earliest. This may lead to sea level rising. As an island, Singapore is most vulnerable to this change. A possible increase of 1 meter in sea level by the next century will result in great economic loss to the country. Moreover, as Singapore progresses towards urbanization, it saw a rapid reduction in vegetated areas and an increase in impervious surfaces, which lead to a heat island effect. Most climate-related disasters are caused by increased carbon emission. Given Singapore's scarcity of land and natural resources, the country is heavily dependent on imports for food, materials, and goods to sustain daily living and economic activities, which eventually drives carbon emission. To combat climate departure, there are two categories of methods for carbon reduction. The natural method calls for reforestation, which stores carbon in the trees and in the soil. Technological methods uses machines to directly capture carbon dioxide from the air or store the carbon dioxide emitted during the production process. In comparison, reforestation is the more ideal method as it has many other potentials to benefit the urban environment. Thus, to effectively mitigate the impact of climate change, we need to enhance the resilience of the city, and the way to do so is through ecosystem-based adaptation. The Reforest City Studio site is located at the former Tanjong Pagar Port, which is currently a vacant plot of land. Zoning in, it shows the site positioning in close proximity to the city centre and sea connection towards Brani Island and Sentosa. This map shows the current effort of M Parks developing urban parks to eventually meet up in a loop. This is a development in progress and it shows the potential of the site to serve as a connector for the parks. Furthermore, 3 new mass rapid transit or MRT stations are planned to be built to serve the area by 2030. The closest station will be a 10-minute walk from the site. In response, our studio has identified 2 significant and contrasting scenarios for the master plan titled Symbiosis and Self-Sufficiency. Now I'll pass the time to the first group focusing on symbiosis.
The first Reforest City Master Plan proposal, Urban Nature Symbiosis, explores the integration and coexistence between man and nature. This scheme aims to introduce forest ecosystems and biodiversity into the context of high-density urbanism, promoting the growth and flourishing of biological and ecological systems, which are nature's solution in combating the growth concerns of climate change and urbanization. Such adaptation to the integration of forest ecosystems may raise concerns as instilling a symbiotic relationship would require different attitudes and mindsets to be set towards how we perceive urbanism. On a personal level, man would have to adapt to living in an environment that would be increasingly naturalized. Taking all these factors into consideration, this proposal explores the boundaries of both controlled and uncontrolled rewilding systems to achieve a mutual coexistence and symbiosis between man and nature. Aspects of resilience have also been carefully considered to secure and ensure longevity against potential future hazards and threats such as climate change. With the intention of achieving 90% reforestation to obtain carbon neutrality for the site, prioritizing and protecting growth of the trees is crucial. The external site periphery aims to control and protect the ecosystems and biodiversity within, whereas internal site conditions focus on encouraging a mutual symbiosis between man and nature. The site's core features the densest part of the forest, where uncontrolled wilding thrives. Radiating out of the central core are more controlled forests incorporated amongst human dwellings. Ecotones in between such zones help to blur the boundaries, providing an inclusive environment that integrates communities together. This is the proposed master plan. The north entry of the site features a site reception at the periphery that separates the forest and the cityscape, helping to control biodiversity. Ecotones and bioswales are then present to provide a gradual merge between the uncontrolled forest core with the residential dwellings to better integrate communities together. Next, the densest part of the forest features ecotourism activities that encourage intimate relationships with nature. Porous residential dwellings explore using a vertical programmatic system to allow man to live in harmony with nature. Finally, at the coastal edge of the site, accommodations help to mitigate coastal hazards such as sea salt dispersions and sea level rising, through various techniques such as wood wide web effect and the ramp effect. This concludes a short summary of the Urban Nature Symbiosis Master Plan proposal.
Our next master plan is titled Self-Sufficient.
The key issues that the master plan are targeting are namely carbon emission and urbanization. It aims to adopt carbon sequestration through mass-engineered timber and create a reforest city that reduces carbon emission through more forest and green transport. On the other hand, urbanization opens the possibility of vertical plantations, which eases the load on land scarcity. The approach on self-sufficiency aims to create a resilient city that is able to thrive without depending on external resources. This is a pilot project that explores the concept of being fully self-sufficient with the aim of being a model for resilience and sustainability. The site's first strategy consists of closed-loop systems to achieve self-sufficiency in terms of food, water, renewable energy, logistical transport, construction materials, and leisure amenities. These system of systems consist of integrated and tightly woven layers. Firstly, transport networks and logistics are pushed underground to free up space for reforestation on the ground level. The extensive subterranean cycling network offers opportunities for users to unwind. Water slope is a water network that serves as the spine of the master plan. It collects, stores, and cleans rainwater for consumption. Spiral Plantation Towers houses 11,000 residents, and the verticality of the tower maximizes the amount of trees planted. The elevated walkway protects the forest floor from human activity and allows biodiversity to thrive in a largely undisturbed natural environment. Food towers and terraces offer opportunities for residents to participate in farming, trading, and selling of crops. Finally, floating solar clouds tap into the airspace to increase surface area for solar energy harvesting. The master plan is divided into 3 phases as part of our second strategy. Phase 1 involves resource gathering, Phase 2 involves a construction period, and Phase 3 signifies a stage of 100% self-sufficiency. Our third and final strategy was to build up the master plan resilience. Using the city's resilience framework as a major consideration for our design, we hoped to embody at least 5 out of 7 qualities of a resilient city. To conclude, this master plan marks a paradigm shift as to how resources can be gathered and distributed, and it illustrates the possibility of it achieving a high degree of self-sufficiency, which can eventually serve as a blueprint for the rest of Singapore to follow. As a summary, we covered the multi-hazards that Singapore is vulnerable to, and the studio has proposed 2 master plans in response. The symbiosis city focused on how man can coexist with nature when it takes over the built environment, while the self-sufficient city proposed systems to ensure self-sufficiency to strengthen the site's resilience against disasters. With that, we've come to the end of our presentation. Thank you.
Good afternoon. My name is Renato Alanzon. I am coming from the Catholic University in Santiago de Chile, and I am here to present to you the studio that we developed with Professor Roberto Moris and Cristina Visconti, two of my colleagues in Santiago, who in this occasion collaborated, as in previous occasions, with this research project entitled Multi-Hazard Santiago, Underlying Risk Factors or Drivers for Resilience Assessment, Integrated Planning and Design. This is a studio we developed with students from the School of Architecture in the graduate level at the university, and we are happy to show you a little more about it that you will be able in this occasion to share with us. The main argument of our studio was what is a characteristic in the case of Chile is this culture of multi-risk. Chile is a country that is affected by a number of risk and disastrous events very often. They are growing in diversity and in number, and we have happened to develop as a country a culture, quite resilient culture in front of earthquakes, hurricanes, not so much, but also volcano eruptions, flash floods, etc., etc. So this is a context where we are already familiar with several events, as you can see in this picture, some of the most recent ones. In 2010, we had the 8.8 earthquake and tsunami in the southern area of the country that was left a very strong impression in our recent history. But not only this one, more recently we had several other forest fires, volcano eruptions, and flash floods as in the north in 2015 and 17. We have had the occasion of working in several of these, like in 2010 and 2015-17. In driving or learning from this experience, we have tried to articulate our approach in what we call underlying risk drivers. We call them in Spanish factors that basically could be considered as those conditions that are more permanent than the occurrence of the event itself, and that condition it in a variety of ways, more often than not towards building up risk conditions and eventually driving to catastrophes. So in the studio, we opened a variety of these, in many cases related to water, but also to the seismic conditions, the topography, the urban pollution, and propose our students a number of problems to address, like rain, flash floods, droughts, earthquakes, tsunami, waste, air pollution, etc., and eventually develop these problems specifically, as you will see later on in this presentation, and also in the Miro boards that you will visit. The method was rather oriented towards the research. We identified a problem, we formulated and articulated in a question, and we developed the research substantially with first and second-hand material around the area of the city of Santiago, which is a regional context that we encompassed between the Andes to your right, which is the border to Argentina, and the Pacific Ocean to the left. So in this cross-section, included but not limited to the city of Santiago, we explored a number of, here you can see the topography, and the cross-section that we actually defined for studying the area and associating it with these risks and underlying risk factors in this set of 11 cases of studies, including the urban area and the foothills of the Andes towards smaller cities and the coast area too, around the basin of the Maipo River, which is one very important water course in Santiago. So the students, based on these, develop each a particular identification of a problem, question formulation, and development of the research that you will as I say, be able to understand in more detail with their help and the materials in here. As a very brief overview, I present to you here some of these works, like the one of Begoña Fonmares, who worked on understanding the threats and the foothills of the Andes in the interface between the Andes and the city itself, these little creeks and ravines leading to floods that have been documented not so long ago. The latest big one happened in 84, 86, and was quite interesting to explore in the hands of Begoña, who conducted an interesting work. Diego Felmer, he worked in a more urban area in a floodable park that was specifically designed to that end within in the inner ring of the city of Santiago, and explore the articulation of these recently developed infrastructure in relation to its immediate urban areas, streets and blocks, etc. Raúl Bustos, he worked outside the city in a small village called Peñaflor, where he identified the historical patterns and the way they were consolidating over time towards, also in relation to the Maipo River, build on the underlying risk drivers. Candelaria Riveros, he worked also along the basin of the river on mass removal specifically related to a very strong topographic condition, an edge where against the local hills, the river twists and somehow embraces the city in a particular way, driving also to specific questions. So in a similar area, rural context and small villages, two different approaches, one more historical, one more related to the landscape. On the coastal area, Andrés Garnier, he explored the project for extension of the port of San Antonio, the main port of Chile, and studied the potential and expected impact of this extension and development in the mouth of the Maipo River, which actually reaches the ocean right south of the port, as you can see in this area of photos and maps driven by him. So he explored particularly the effect of this intervention in the near shore of the river and also the interface of the city, finding threats, but also potentials for development. And finally, Sofia Bazan, she worked in a very specific, rather touristic resort or little village, Santo Domingo, where she underlined the differences between these two particular patterns, one of those tourists, one of those working in the tourist resort, and the way they were related to the seaside and also to the river area too. So having made this very brief introduction and summary of a few cases, I invite you to visit and enjoy the work of our students, who I am sure will also enjoy your work too. Thank you and have a good event. Bye.
Great. Congratulations to the different teams, to the teachers and students. It's amazing to see these works and how the different approach is possible to recognize using these approaches in other parts of the world. I think it is I really like to see this community. Even in the case of Chile, is more focused in analysis than projects. I am sure that we will take advantage of your projects in these different cases, and congratulations again. And we will start with the student questions. First, the National University of Singapore is asking to Tohoku University. Go ahead.
Hi Hi, Sarah. Thank you for the wonderful presentation. We really liked how the systems managed to integrate both the evacuation routes and the social cultural aspects to revitalize the site for tourist attraction, flourishing biodiversity and social activities. So, as mentioned in the video, the residential areas are shifted inland and evacuation routes are weaved as green corridors. How long then does it take to escape from Uragai port to safety in the event of an earthquake or tsunami, and at which juncture is considered safe?
Hello, thank you for your question, and it's a very pertinent question actually. So after the 2011 earthquake in Uragai, the Netori disaster management group established the reconstruction plan for Uragai and relocated the whole residential area to a raised area. But for our proposal, we proposed the green corridors to make it easier for the people who are using the coastal area and the residential area to quickly leave the damaged places. And we didn't establish like an exact measure of time for being able to leave the damaged area as a precise measure, but we know for sure that these corridors are managed and are thought to be completely free during a disaster time, and these corridors are integrated within the cultural community. So they will be used on a daily basis, and people will be aware that these are areas for evacuation. So keeping this in mind, it will facilitate for them the way to go out of Uragai. And especially like these evacuation routes will be connected with the main routes of Natori River and of Natori city and of Sandai. So then they will evacuate as fast as they can, because previously they only had like only 1 or 2 evacuation routes, which was really a narrow place to evacuate the whole Uragai place. But now making the evacuation routes multiple routes and available to be used in daily life, it will definitely be easier for them to use it. Okay. Hi, it's done.
Yes, we have more than minutes. If we have another question from Singapore to Tohoku, we can use it that minute.
Okay, sure. So another question would be, the landscape is beautiful, so is it accessible to vehicles to access the site to evacuate the people?
Yes, actually, we recreated the whole landscape of the area in order to make it a better touristic attraction for tourists and for local people. Before the 2011 earthquake, Uragai benefited from beautiful beaches, from the Taizan Canal, which was a landmark for the international network production, and people used to visit Uragai for its multiple potentials. But after the 2011, we noticed that people are not anymore attracted to visit the area. They are more scared about this. So we emphasized about recreating the beautiful landscapes of Uragai in order to recreate this attraction and make it and serve this the disaster mitigation culture through landscapes actually. So yeah, I think this is a very strong point for this project. Through the corridors, so the evacuation corridors, which will be planted through the festival routes and the festival plazas that will be beautifully managed, and also through the system 1, which will be located on the coastal side, and it will inhabit aquaculture and aquaponics, which are new possible production manners for the local area, and that will actually create a new image for Uragai, and this image will be transferred on the abroad a broad area for Sendai and for other Japanese region and make it attractive for all of them.
Thank you very much. Now is the turn of the National Cheng University to Singapore.
Hi. This is Ho from NCKU, and we understand that you want to solve the problem of carbon emission and promote the economy. But it seems that vertical front is a good solution for those issues. So we want to ask you why you choose to build a big park instead of building a vertical front in project 1.
Hi, I'm Joanne from NUS. So thank you for your question. Project 1, you're referring to the one about symbiosis. Is that right?
Yeah. Yes.
Okay. So, frankly, it was tough to squeeze 2 master plans within the time limit. So apologies if you missed out on any information that you may be curious about. But actually, during our intense research before the proposals, we did try to come up with a ratio between the built environment and the natural environment in order to achieve carbon neutral just from carbon sequestration from the trees before we have any technology kicking in. So the ratio was actually 1:9. And I'm from the second master plan, but the first master plan, they actually did try to come up with a few configurations of how they can integrate the built environment with the natural one, because what their focus was this interface and relationship between the people as well as the natural environment. So because trees only grow to a certain height, they actually did not want to go so high, so that because they are afraid that there may be this disconnection between the people as well as the natural environment. That's why they tried their best to keep everything as not too high, but sufficient enough for them to have visual and even physical connections with the environment around them.
Okay, thanks for your reply.
Thank you.
We still have
a
second question. Okay. We have another question for the project 2. We saw you do a lot of things on this area, like you asked many strategies on this area. So we want to know if there have any chances that won't only appear in one phases, like you have 3 phases for your strategies. So if there is any structure or something only appear in the middle phases, or like it won't appear for a long time, only appear in a short time to support your ideas to develop, to have a good development.
Yeah, thank you. So regarding the phases, actually all systems will last a long time until the end. Just that some systems may kick in a bit later than the others. So just to briefly summarize, the first few ones would be like the water and the underground transport, as well as some of the solar clouds, just to ensure that construction can take place. And then from the second phase, there will be the food, and the food will come in. And then finally, the social walkway will start coming in when the site is fully functional. So yeah, just to answer your question, they all last a long time, just that they start coming in at different phases. Yeah.
Okay, thank you.
Thank you.
Thank you both. And now is the turn of Catholic University to National Cheng University.
Hi. First of all, say that we like a lot your proposal, and we think that is very, very good. Our question is not more about design itself, it's more about in the participations and stuff. Like, for example, you have consider asking the local government or even the people that lives there how you would like to manage all these, I think, 100 years proposal, or how, in which part do you think that it should be important to consider it?
Hi. Hello. Can you hear me? Okay.
Yeah.
Yeah. Thank you. I'm from the Cheng University. Actually, in the previous survey and study of the site, that we found the most important problematic thing of the site is the erosion of the coastline. And this is because the previous reservoir accumulates all the sand so that the sand will not go into the ocean and make the coastline erosion happening. So the main idea of this project is to think about the problem of the erosion. And the main problem of the site is that the artificial dike is going to collapse in very soon. So the idea is to allow the dike to collapse and let the water comes in, so the erosion happens. But we think maybe in the future, around 2060, the present reservoir now is going to have a new life cycle. So there is going to be a very smart group of the scientists. They will come up with a very good idea to fix the reservoir and allow the sand to come into the ocean again. So then the coastline will then be in the balance. So that's the main idea, because we cannot. The main idea is to think about what we can do now and what is the better way to face the erosion. And we want to allow a period of time that we gave in this site, and so then there's going to be activities going on, and industry will goes on too, and there will be some better plan for the reservoir to revive in the future.
We have just 15 seconds left. I don't know if you want to go deeper to the question of another question.
Maybe just ask them this network system that works like tourism and educational and aquaculture, etc. Is this how would this manage over the years? Who will be like promoting it, or how do you think that it will work?
Actually, it's just a proposal of the lifestyle, and we think because the main idea of this activities is to support the local economy. So if the economy is good, or it is going to be better than before, then the activities, the humans, the people living here is going to have a better life. And this is the main idea of the proposal. Thank you.
Thank you. And now is the turn of Tohoku University to Catholic University.
Okay. Thank you very much for the great works and presentation. My name is Zhou Zihan. I'm from the Tohoku University. So in the presentation, you have talked about the underlying risk drivers, or you can say the underlying factors. Also, in some of the rural areas, you mentioned that the historical approaches have been found in consolidating towards a micro river So here's a question: that is there any evidence that the local citizens or the city developers have already been aware of the potential risk drivers and conduct the urban construction and expansion accordingly? If so, could you give some examples? And if not, what's a proposal on nudging the developing process facing such factors? Thank you.
Yeah. We think that actually the people that live there, most of it is like informal urbanization. So it's not like, we think that most people may be known, but it's like, it's not formal, like how this is planned. Actually, it's not planned at all in most parts. And that's why, for example, we talk about one park that was made in the city itself, in Santiago, that has this condition of being resilient to flood. And these small other cities that had the river near, it's a different condition about the big city of Santiago. According, for example, to the coast cities, there is a difference because there is known that in our country we have tsunamis and we have earthquakes. So people know that actually it can be a tsunami anytime soon or even an earthquake. So most of the buildings and the plants and the cities are like aware of this situation, and that is why it's prepared for that, and they are prepared for this kind of events. Actually, in this studio, we like go more for and research real deep to understand all the factors that we have to analyze before doing any design, architectural, or urban project. And as my teacher says before, this studio has not been like a final proposal, but we have made a few diagnoses to the idea to trying to understand the different risks that our cities in Chile have nowadays and even in the future. That's the idea that we have to know that in there, the vulnerability of these cities is always affecting the same people. Actually, the housing and all the same cities and the same part, because we have a weak governance, and we had a social crisis in 2017, then we have the pandemic. I don't know. I think that actually these cities, we are like a very resilient culture because we have to deal with it over the years. And most of the people know that they have this risk in any moment. So I think that answering your question, the people know most of it, there are some risks. And that the way to maybe to defeat them or even like being resilient with them is like just trying to understand how they work, and in the future trying to have a better system, a better planning, and a better solution for all these things. So I think that there's where the design and the architecture and the urban, we have to follow and go there. Thank you.
Thank you very much.
Thank you, everybody. Very good questions and responses. Thank you very much to everybody, and congratulations.
Okay, I think we're have concluded now with the student presentations of the work by the students, and the exchange through question and answers. It's been fantastic. We weren't really sure if this format would work. I think it's been a very successful format. It's been very interesting to see, not just see the students and the students' work, but to see how they also respond to other works many along the same themes, but also obviously different locations, different conditions. And within the context of that, to be able to bring it together in a whole new way of understanding both the projects that they've worked on, but how these projects might be developed further. So thank you all to all of the universities, to all of the interlocutors, and particularly to all of the students for their time, their energy, and also their attention to the issues and the themes that are being developed through the ArcDR3. So thank you very much. Now we're moving now into a slightly more extended session for some conversation and discussion, and to draw out some of the threads, both from the work that we've seen, as well as the work that's ongoing, and as the work will be developed further for future forums, future exhibitions, and future publications. But before launching into that with a selection of representatives of some of the teaching staff from the different universities that are participating, I just want to express some thanks, some sincere thanks to our sponsors, because in fact, we wouldn't be able to put on these kinds of events and to carry the depth of research that's going on without that support. So first and foremost, I would like to thank the Mitsui Fudoshan for their generous support for the ArcDR3 Initiative. It's been fantastic to have that support and have that ongoing support to make these happen. At the same time, we also want to give thanks to the partners and other sponsors, including the IRIDES at Tohoku University, the Mirai Khan Museum of Emerging Science and Innovation, and the UCLA X Lab in the Department of Architecture and Urban Design, the Terasaki Center for Japanese Studies and International Institute, and the APRU. And obviously to the 11 participating universities, which stretch across 8 different countries and 4 different continents. So it's really quite a broad and expansive group that make up this ArcDR3 initiative. And it's really forging new connections, new exchanges, new cooperations, and hopefully we'll be able to put all of that energy and all of that intellect into a format that can be distributed much more widely. Now, the next section that we'll work in is we have about 20 to 25 minutes to go through a series of conversations and a little bit of expansion on some of the work that we've seen, as well as the underlying themes and research that have been taking place. So I'm rejoined by Lyra, by Jeffrey, and by Roberto. But we also have with us now, we have Natalia Echeverri from Hong Kong University. We have Ken Tadashi Oshima from University of Washington. We have Shu Mayan from Tsinghua. We have Roland Raul from UC Berkeley. I'm looking around the screen. I don't think I see Roland on here. But we have Shinya Okuda, who's joined us from NUS. And we have Yoshiaki Anoda. Maybe not. We have a few no-shows. Sorry about that. Okay. But we do have with us also from NUS, we have Tatsuto Sakamoto. Thank you. So I wanted to start, I'm going to group this a little bit just to kind of get the conversations going. And so with having Natalia here and Ken Oshima, from Natalia from Hong Kong University and Ken from University of Washington. Your teams also, along with Lyra, also work primarily under the category of water. And so as a kind of rethinking about that, I mean, obviously, water is not itself a singular condition, and particularly when we talk about disasters and consequences. We could talk about tsunamis and it. We can talk about the sea level rise and it's happening. We can talk about flooding. We can talk about the effects of pollution and what it does to our water systems. We can talk about increased salinity through various processes, whether they're agricultural or also in terms of sea level rise. And we can talk about erosion. So I want to pose maybe a question to Natalia. In Hong Kong, you know, the project, as the students presented, is dealing both to a certain degree with not necessarily about the coastline, but the presence of sea level rise and the relocation. But also we heard about the issues of flooding and about the rain that you get, this very tropical kind of rains in Hong Kong. So I'm curious if you could say a little bit more, particularly in the kind of research that the students have been undertaking and how you focus on that. And I guess the decision of what is it that's most at risk in Hong Kong as part of the research.
Yes, hi, hello, thank you for having us. The students, the way we started the studio was that we started looking at different dynamics that were caused by climate change and sea level rise. This included the typhoons or storm surge, which every year there has been an increase if you look at them historically. Also, the effects of sea level rise. Although Hong Kong has a very engineered seawall, the effects of sea level rise and storm surge, if they come together at a high tide, there's bigger consequences. And we were also looking at water in terms of water scarcity. Hong Kong receives 80% of their water resource from mainland China. So a lot of the water, it rains a lot here, so a lot of the water gets just disposed into the ocean. So some of the projects, maybe not so much the ones that presented today, we're also dealing with that of how do you catch water as well. So the studio basically began with looking at all these dynamics in terms of wind as well because of the typhoon, and in terms of water catchment and sea level rise and storm surge. And then once this kind of like idea, like finding, what we started was working with 6 different sites in the studio that had different conditions, but were all coastal sites. Then the students started working in groups to understand kind of like the different dynamics that were in each site. And then they started to create proposals of how to deal with these dynamics before coming up with the strategy of the tower. So at the end, I think in general, the studio was focusing, like I think the big part of the studio was how the tower touches the ground under the different conditions as well.
Okay. Thank you, Natalia. I want to jump to Ken, if I may. Ken, I mean, I was quite impressed with the presentation of your students, but I was also impressed in the very interdisciplinary nature of the studio itself. I mean, the students, at least the way I understood from their presentation, were, you know, planners and landscape and urban designers and architects and a whole range, but there were also, they mentioned in their conversations a great deal about social feasibility and community engagement and stuff. So I wonder if you could talk a little bit about how you bring together a kind of diverse group like that of students in order for them to be able to do that work and make the exchange happen.
I mean, it's very interesting in that that's the core of the challenge of the studio, of coming together in an interdisciplinary way to attack these problems in these sites. We looked at Westport, South Beach of Washington, which is separate from what people know of Seattle and the more urban areas. Westport has a population of about 1,800 people, so certainly very different from Hong Kong or many of the urban sites that other studios have been looking at. But it's perhaps in that kind of direct contact with the population of this area that we were able to have working with the director of public works and other people directly related to this area, various populations that we were able to kind of really strategize in a direct way between all of the different students, but also the populations that we were affecting. And so it is, I think, perhaps unique in this configuration of the ArcDR3 and how the planners, landscape architects, both undergraduate and graduate, actually, students, were able to really come together and share their expertise, and but yet really learn different disciplines or languages of how they operate. And so it's in that, but even the site of where we looked in Westport, there are aspects that are directly facing the Pacific Ocean, so directly in the line of tsunami danger, but other slightly more inland areas that are more directly affected by sea level rise or other factors. And so although it is in a fairly focused area, really trying to strategize in these specific points about the different aspects of the different challenges that water in a more general sense poses.
Great, thank you, Ken. Okay, we should have had a representative here from Tsinghua and also from UC Berkeley for this next session, but they're not here. But this is really to move on to the thematic under Earth, Wind, and Fire. So maybe I'll jump back to Jeffrey because you hosted the session with the students on that. And now that we had a little bit of a conversation about the role of the thematic of water, I'm curious if you have any thoughts, having seen the work of the different universities under the category of Earth, Wind, and Fire, are there particular responses, or are there particular ways of working, or are there particular conditions in that you saw in the work, and how it sort of registers itself as a research and a design project?
Yeah, Don, I mean, I think all the proposals were really smart. The thing that threaded through a number of projects was the idea that everyday life can be integrated with the looming disaster in a way that doesn't normalize it to the point where people are living in fear. And I think that was a really smart move by the students, that there was a priority on establishing social networks and education about the potential for disaster, so that the social network would be the very source of immediate response, and that social network would be the foundation of recovery. So, and that smartly, with all of them, it wasn't so much about prevention as it was about establishing the social network. And as we know, something like 80% of people who first respond in a disaster are neighbors rather than professionals. And I think that they built upon that idea, that notion very, very well. And so the idea that that fire threat could be integrated with weekly farmers markets, that energy production could be correlated to fire season, the idea that that there's a continual spectrum from pre-disaster to post-disaster where preparations could occur, as in the University of Tokyo proposal, I think were really powerful. One of the things that seems really important as educators is that we ask of our students in our studios for exportable findings, meaning things that that we collectively have learned that we can take away and apply to other situations. And I feel like that in some cases that was articulated. In other cases, there was too heavily a focus on process, and the detail of the design over what I think is way more important, and that is that we as architects communicate an understanding that goes beyond our discipline and begins to influence people in decision-making roles and helps to educate stakeholders in terms of the risk-reward dynamics within any kind of disaster situation. And that's why I find the wine urbanism such an interesting project, because it's a risk-adjusted benefit that they're understanding. They understand that the wineries will be damaged if there is a fire, but the net risk reward in that situation is that the rest of the city will be less damaged, and that investing in creating greater vineyards will mean that there's a risk that there will be greater damage in any given 1 year. But that damage is something that is outweighed by the benefits of the potential for recovery and economic continuity. So something like that kind of finding that is extractable seems really important to convey.
Yeah. Let's jump then quickly to NUS and Professor Okuda. And also maybe Roberto, you might want to come back into this. I mean, both of you represent the sort of multi-hazard research and design agenda. But Professor Okuda, would you like to give a bit of a background, maybe both from NUS, but also having seen the other projects from Pontifical and from the other universities?
Thank you very much. Yeah, from the NUS, we have two projects reacting to the climate departure or global warming. One is sea level rising. Sto is here, and my studio is working on the reforest city. Maybe I comment in general overall that through the student presentation today that we observe the three learning and organizational challenges, and which seemingly coming from the maybe a scale of the issues that we are dealing with, and also multidisciplinarity. First of all, I think it's a research and design combination that I think everybody, perhaps prior to design something, the regenerative, resilient urbanism, perhaps all of us studied and understood the wide variety of the ingredient of the cities, the urbanism, and the nature, such as the economy, environment, social, and the nature sides like water, air, sun, and wind. That itself was a pretty overwhelming experience, especially our studio, NUS side only allocated 4 months. That I think every student was a little bit overwhelmed. And the second challenge was the master plan in relationships to individual projects. Master plan, as we know, it's a highly collaborative the process, while that we are from the Department of Architecture. Architecture students tend to go for the individual project as early as possible. So our management challenge was that how to keep the individual student to stay in the master plan collaboration process as long as possible, which in the end eat up their individual design time. So that was really struggle as a studio leader. The lastly, that it's a nature and urbanism. both nature and urbanism has their own complex systems. We spend our time a lot of understanding the nature, how the nature system works. But then when we start to compose the master plan, we also need to learn how we could actually build up the urbanism in harmony with nature. That's really challenging in terms of organizing the studio. Thank you.
Thank you. Roberto, did you want to add anything there?
Yes, maybe to say that our school is a school that has been very focused in architectural design. We are very happy to have very good architects, quite famous in Latin America, but at the same time, in these years, we had been with my partner Renato, had been trying to take some steps back to see how we can reimagine design in a different way. Not but because it's a unique way, it's because we had been trained mainly putting focus in the object, but at the same time, we are living in a very transformative world, and not just because of natural disasters, is because the whole world is changing. No, even before the COVID in Chile, we still living this social disruption that we started in 2019, and it's similar to Hong Kong and other parts, and even states, and we want to, because normally we had been teaching design in postgraduate students, and for me as a designer, it's very attractive, and it is why I really like the design projects of the other students. But we wanted to go to the first stages of the students of architecture, trying to think what is before the design, what is the ideas that we need to recognize watching. Really, it's mainly to be with your eyes and your ears very open, because risk management is mainly to be aware. And now it's not, because in Chile we know about earthquake, everybody is trained for that. But the problem that is, we will be facing different kind of disasters. And now we have been living actually a real disaster, social disaster, and the sanitary disaster because of the COVID. And the poor families are again the most affected families, and architects, and especially my school is focused mainly doing architecture for rich people. Most of my colleagues, and even myself, we had been working for wealthy families because the good jobs, the good projects are there, are good projects for good architectural magazines. But we need to be focused in the real issues, and that is why we started with students for fourth semester and trying to be, okay, please don't design, think before, observe. And I think that is something why we are really enjoying, because we can see how the different approaches of the different universities, we can take advantage of that. And the same way how our students, if they are more aware, maybe they can work everywhere, because because finally it's people and territory, and that is the way how we really believe that architects and urban planners would be more aware to be more political actors.
Okay.
That is.
I'm gonna jump in there. I just want to get a few more conversations. Maybe I wanted to, Hitoshi, Professor Abe, if you're online. I'm interested, one of the things that's come up, and this follows on a little bit from Roberto's, in projects like this, there's often a kind of, it's not a disconnect, but there's the kind of research everybody's doing research and background and trying to understand the issue, but then there's this desire to come up with a solution, or at least a design-led response. And sometimes the designs don't have a lot to do with the research, or sometimes the research almost challenges people to suggest what a design. So I'm interested, as someone who's originated this initiative, what are your thoughts on what we learned through the design process, as well as through the research and background?
Wow, I mean, you just throw me the very heavy question. But actually, that's been the struggle. But also that was the focus of our studio. I mean, Jeffrey and I both led the different studio, but sharing the similar syllabi. And we try to make a smooth transition from research to master plan or master strategy to the architectural design. And I'm not sure if it's successful. We see that there's a couple of successful projects to sort of take the strategy as a way to respond to the some of the aspect of the particular phenomena, and then the strategy somehow led the design idea, but in large, meaning that the particular shape and the particular gesture of the building, I'm not sure if how closely it's connected to the actual solution. But I think there's still possibility. Let's say we wish if we have more time to explore, but I think there's a possibility, and there's a certain fact that maybe Jeffrey can talk about, the relationship of the shape of the landscape versus to how the fire behaves, and a certain kind of a distance issue about how to protect the house from the fire. So there's some kind of spatial aspect and a material aspect that can be transferred into the design itself. So I still have a hope, but we need to explore that. But also responding to that question that Roberto actually raised, like actually this morning we got the email from the media asking question, how this will be reflected to the reality of the disaster itself. So that means we learned a lot from the reality of the disaster, and then we went through this, but how can we actually connect what we've done back to the reality? And that's another thing that we kind of have to answer. So that's something that I'd like to ask also to all of you, actually.
Yeah, and maybe, well, we don't have much time, unfortunately. And I'm sorry I didn't get back to Lyra and to Professor Sakamoto. But, I mean, I know that, with the UNUS team, you're doing two projects, not just the multi-hazard, but also the water, which was part of Lyra's group. And so there's just a range of questions. I mean, we've tried to structure this to give us a bit of time for a conversation, but as usual, we always run out of time, and we never really necessarily get as far along as we would like. But again, we should probably not see this as an ending, but again, just part of the starting, because we're still going on with the projects. There's still, and at the end today in this event, Professor Abe will come back and give us some indication of the stages after today and where this initiative, this ArcDR3, goes forward as an initiative. So I want to thank you for participating. I'm sorry we didn't get a question with everybody, and we didn't get to have an extensive a conversation as we might want. But we've added a section here that we're moving to now because, as I mentioned at the very beginning, we're in an unusual condition of setting together through the 11 universities a sort of research and design program dealing with disasters. And what happens, we find ourselves in a completely global disaster of the COVID-19 pandemic. And it's had an effect on all of us. There's no place in the world that hasn't been affected by it. So irrespective of the categories of disasters that we've been researching, where some places don't have earthquakes and some places don't have the same concern with sea level rise, and some places don't have some of the same issues with water or fire, we all have the issue of the pandemic. And so it was really the students we've all had to work with this, but the students in particular have had to work through this in doing their work for this forum and as part of their academic education. So we wanted to bring some students on board, just a sort of representative selection, and just get a few indications and a few little stories from some of the students. So thank you for joining us. We have a student here. We have John from NUS. We have Zihan from Tohoku. We have Christina from University of Washington. And we have Claudia from University of Melbourne. So I'm going to throw this first to Christina and ask you, Christina, what were the it's hard. I don't want to make it so broad because there's clearly lots of problems that happened under COVID. But from your point of view, I want you to name me the worst thing, but also the best thing that happened under this condition of COVID-19.
I think I'll speak to the challenges of coming into our interdisciplinary studio as one of the planners who. The thing we wanted to bring to the table was community voice, and that tends to be an aspect of urban planning that we can lean on. So community engagement and being able to reach out to folks in the community we were working in Westport, which COVID made impossible. Folks were remote at the elementary school that we were going to be partnering with quite a bit, and being able to reach out to different stakeholders in the community became very challenging. So we weren't able to kind of complete the loop in the way we would have liked to. I'll say one of the successes, though, one of the things that was a really cool opportunity to be doing something so what seemed like a big undertaking at the time still really does during COVID was how ingenious you kind of have to be collaborating with so many different groups of people from very different backgrounds and experience, architects, landscape architects, and urban planners, and trying to find a way to harmonize those things digitally without ever meeting each other in person, and without having actually visited. Most of us had never visited Westport because of the distance from the University of Washington, where most of us live near. So it made for some interesting problem solving and troubleshooting, which was a really worthwhile experience, I'll say.
Great, thank you very much, Christina. Now I'm going to move over to Zihan from Tohoku. Can you give me the same thing, as brief as possible, but cover over both some of the worst things, but also some of the best things that came out of dealing with COVID?
Okay, so during the COVID-19, so our laboratory was totally closed for a long period of time, and also about half of our courses and presentations are operated online. So in my opinion, if the first and most emergent problem is that it becomes very difficult for us to research on site. So we are more than ever reliable on the Google Map, including the street views, the topographic data, and also the 3D data online. But I think it's a good thing that we can, or you may say we are forced to see the site condition on a larger point of view, and with the broader data, we often find some interconnection between the separate districts. And however, we also found out that some of the data is out of date. For example, the photos uploaded to the street views in Google Maps, where the East Japan earthquake in 2011 occurred, are mostly shot in 2017 and 2016. And when we were able to finally do the site research, we were surprised to see that the places has become a kind of large playground for kids. So it's totally different from what I saw it on the photo, barely nothing. So it is very interesting to be able to see the gap of time that the specific area is connected to its historical context and changes completely in the process of the reconstruction formed from disaster.
Okay, thank you, Ziha. John, I'm going to jump to you now. Specifically, I'm interested in the conditions in Singapore. I mean, in Melbourne, we read about Singapore, that there was a time when Singapore seemed to be doing quite well, and then suddenly it went kind of back into lockdown. So I'm curious what effect there was with you and your friends and colleagues.
I think because recently we have another surge of cases, that's why we went back into lockdown. But I'm not sure if I'm in a position to say this, but I think Singapore just we just have really strict and safety measures to, like, we call it the circuit breaker thing. So like is to break normal routine so that like the virus wouldn't spread too much. But yeah, so going back to lockdown, I think it's pretty much the same as before because everyone is starting to get used to working from home. So yeah, it didn't really have an effect that much. Yeah, but I would say like the pros about this situation is that collaboration seems to be quite effective online. Like, sure, we have the same problems with like going to sites, like everything is closed, like they don't allow more than groups of 2 or 5. So we face like site visiting problems, but yeah, collaboration on the internet seems more effective because like we can have 5 people sketching at the same time, and it's easier to communicate. Like you can and in different hours of the day whenever the group is free. So in the collaboration aspect, it's pretty good.
Okay.
Yeah.
Okay. Thank you, John. And now I'm going to move to Claudia, which I'm much more familiar with the situation. So I want to draw that out just a little bit differently, maybe. I mean, certainly in Melbourne, we went through a very strict lockdown for an extended period of time. But also, being the way the University of Melbourne works, we also have lots of international students, and a lot of those students weren't able to come back to Australia. So in the group work, it wasn't just that people were online, but they were across different time zones. And some of our students have never even been to Melbourne and are doing projects about Melbourne or around Melbourne. So Claudia, can you say a little bit about your experiences and how that transition both happened, but also what you've been able to transition into since then?
In terms of collaborating with people who are overseas, it turns out that we had 2 students in our group that were, and both of them had never come to Melbourne before, or at least came but for a holiday experience. So they didn't really see the full culture, especially in terms of our project with the agriculture of that side of our assignment. So collaborating over it was a lot of conversations that we had explaining what it's like here in Melbourne and what happens, and especially when we were talking about certain areas, we had to explain a couple of things, and there was a lot of similarities that both here in Melbourne reflects in the countries that they are in at the moment. But it worked very, very well, and I could say that I could put along all the collaborative side into work life as well as going forward into university. It's a lot easier to collaborate over line than what you would think, you know, prior to all of this COVID, because it wouldn't happen as much, especially during assignments. You would normally just go into university and work on the project. But, you know, through this collaboration side, you can see how it can be brought into life when everything eventually goes back to normal. So it was very efficient and a great thing to go to, especially as a student, because you do collaborate with people overseas and throughout the whole world. So it was a very good life lesson.
I mean, we certainly, I think within the university, realized that, you know, through lecture series or other kind of events, we were no longer restricted with who could fly in or who we could afford to fly in or something, we realized that actually it could be much broader than that. And so I'm curious for some of the other students, maybe Christine, do you feel not only that in working with your immediate colleagues that working online is now a possibility, but did you have any sense that actually one of the things it does do is broadens the opportunities that go beyond just who you could meet in a city? I mean, on the one hand, we're not having some of the contacts because of the restrictions, but on the other, it's actually opening us up to contacts that we wouldn't have had even if the city was open, because not everybody can come to Seattle or wherever.
Definitely. There were some points in the process of the studio where the timing didn't pan out to take advantage of some of those opportunities, but long term in some of the prep work going into the studio, and as work has continued after as part of ongoing research that other master's students are doing, we have been in contact with people not only in Westport, but within the county that Westport is in and the state of Washington, whose decision-making impacts that community, and we would likely not have been able to as easily access folks in the positions we are right now in a different context. And so that is something we still get to leverage after studio, which is a huge benefit, definitely.
And Zehan, I want to come back to you as well in terms of, I mean, studio and your professional education, conversations with professors or other teachers or educators, but university is also a time to meet friends, to create networks, to establish long-term, interpersonal relationships. How affected was that? How was that negatively impacted, or how did that actually open up in a different way?
Well, I think that the university in my university, it has come up with an emergency kind of form that it operates before the great East Japan earthquake in 2011. So my university, the Tohoku University, acts quite well to shut down and stop the COVID-19, and at the same time using everything online tools to get us connected. But I think that me myself as a foreign student, I think that what makes a difference is that we all the COVID-19 is more of like a global problem, similar to a global warming. It's not something regional. For example, the Japanese people, they suffer a lot from the earthquakes and tsunamis. But in my hometown, in Nanjing, China, since it's not on the earthquake zone, I've never experienced any earthquake actually. So it's a little bit difficult for me to truly understanding the feeling of fighting, the importance of fighting such disasters. So in my opinion, the COVID-19 in some ways shares us often the foreign students the same emotion and experience to the people and the students in Japan, that makes us all come into some consensus of risk management, and we are open to communicate with each other to share our knowledge and research, even in this global question, because global problem, because we are all in the same situation.
I think that's a really, really important point, and very, very interesting, because it is something that has affected everyone. So nobody can say they're in a privileged position where they don't know anything about it. Everybody knows something about it. But the other is to look at the sort of institutional responses. Well, both the sort of people's response across all levels of people, but also the institutional responses. And as you say, whether we're talking about global warming or sea level rise, or if it is a natural disaster, whether it's a typhoon or an earthquake, the question is always, what are the responses, and when we talk about resilience, it's not just about how do we recover, but how do systems and governmental structures manage when something happens. And you can see the very, very different ways that different nations, different states, different municipalities have dealt with COVID, and see a whole range of either denying it or trying to get in front of it. And then questions like reliance on science, the degree to which, instead of relying on certain prejudices, one is relying on evidence-based work. And I think within this, research schema of the ArcDR3 is this question of being able to use both research and science and knowledge, but also design evidence about ways in which it takes place. And so I think you're right to say that this is a huge kind of global education that everybody has had to go through and is still going through and will keep going through for some time now. But it's I think it's really important to recognize that, we have suffered together at a global scale, and therefore those global problems like climate change, we have to recognize that we have to at least understand it in the way that we haven't always understood COVID-19, but are beginning to learn how we might be able to deal with it. So I want to thank you all for joining us. It's really great to hear from the students again, and to hear from your experiences, and to be able to share in your insights that you've brought to us, and we very much appreciate that. So thank you again for participating. Thank you again for all your work and all of your other colleagues' work, and the work keeps going on. So it's my privilege now to turn this over as a last closeout to Professor Hitoshi Abe from UCLA, because not only is Hitoshi a good friend, but he's really done the background work to get this whole initiative up and running. And so I'd like Hitoshi to tell us what's next and where we go from here. Hitoshi. Sorry, you're muted. You're still muted.
Sorry, how is this? Okay, thank you,
That's
Don.
better.
Thank you, Don. I'm actually totally overwhelmed by the presentation and the kind of conversation, but also just to realize what it means to have this kind of a global education platform. It's the first time for me to really sense it as a real thing. And I'm really sort of really overwhelmed by looking at it. And, we should really kind of continue to push this through, and hopefully at the end we can have a really beautiful grand ending. But first of all, I'd like to say thank you to all of the students who participated to this initiative, and also like to congratulate them for their great accomplishment in the studio works, as well as also interesting discussion at this forum. And you had to go through the series of studies about the disaster under this disaster situation of the global pandemic. But also I'm sure that this experience will become something very valuable in your future. And secondly, of course, I'd like to say thank you to Professor Don Bates. I mean, you can tell that he was the main MC and the driving force of this event today, and also his team at the Melbourne University for their support, and also the coordinators of ArcDR3 Initiative, Lena, Martin, Tomoka, for their hard work to run this forum. And without your effort, actually, we could not get together to learn about and also to celebrate each other's work by the students. And also, lastly, not least, we'd like to say thank you to Mitsui Fudo-san for their generous support of the ArcDR3 initiatives. And also we have many partners, IRIDES at the Tohoku University, Miraikan, the Museum of Emerging Science and Innovation, UCLA X-Lab, Department of Architecture and Urban Design, Terasaki Center for Japanese Studies, and International Institute, and also APRU, Association of Pacific Rim University, and US supports were very important to make this forum to happen. So my real job is to talk about the next step of ArcDR3 initiative. The next step for us is the exhibition in Japan. Luckily, the date of the exhibition is finally set. It starts from Saturday, April 9th, 2022, and ends on Sunday, April 24th. So we are planning to set the opening reception on the April 8th and a symposium on Saturday 9th and Sunday 10th. And this is finally, hopefully, the opportunity to get together in person and have a nice, actually maybe the glass of wine to discuss about this initiative. And also, it is decided that this exhibition will travel to Japan House in Los Angeles, California on September 2022. Japan House is a facility showcasing the very best of Japanese art and culture and more, and I'm very excited to have this show coming to LA. And also, there are many universities raising their hand to host this traveling exhibition around the world, which we are very excited about. So you will know about this sometime soon. But to the participants of the ArcDR3 initiative, please remember we need your cooperation to collect the information about your researches and projects. And we do really appreciate if you just make sure to send us these information as soon as possible. You haven't done so, okay? And we are very much excited about this platform and things gonna happen in the future. And again, thank you very much for your participation, and please stay in touch for the next development of ArcDR3 initiatives. Again, thank you very much.